Thank you very much, Thomas.
Yeah,
if you don't mind, thank you, that'd be grand. So this is me, by the way, in case you didn't know. Have we all had a lovely New Year? Nice Christmas?
Yeah.
Much observing done? Anything special to report? The observing fronts? No?
The Corona hasn't gone on.
Yeah, I've heard a lot about it.
Yeah.
It's cold up there, isn't it? All right, let me get into the meeting then. As I say, thank you very much for coming along today. And I apologise again for the difficulties around accommodations, IT, all the other stuff. It'll be worth it at the end of the day. We've got some great speakers lined up for you, some great things coming along. So let me just first of all, go to my next slide. I have a couple of things to mention here of BAA business. We have two new members of council. One of them is our new meeting secretary, Mr. Steve Foulkes. You may be used to him in a little brown overall he usually wears. Steve, dear heart, come and show yourself. This is Steve Foulkes. I know Steve well because he's a favourite man. Did you want to say anything to them?
No, enjoy the meeting.
Don't complain to him. Welcome, and also to Thomas, who is our new director of the computing section. Good to see you. I have two little presents for you.
Thank you.
So we all know. Thank you very much. So it's good that we've had vacancies for a while and so on. We're always looking for people from the membership who want to get involved. There's lots of jobs that need to be done across council. And it doesn't mean that you have to be on the council. You can approach any of the section directors or the post holders if you just want to be involved in helping out. We do a lot of events and other outside things. All needs people to join in the fray, get things done, even the smallest of things. And we're still looking for an advertising person, voluntary role, to assist the editor of the journal. So if any of you have a strange and wonderful desire to be an advertising manager, Philip Jennings is your man to speak to. It's not that onerous, honestly. Once 2 minutes a day sorts it out, doesn't it? But it gets you more involved in the running the organisation. There's a lot to do. So moving on. So let me mention to you the National Astronomy Week coming up. Who's aware of it already? Who's aware of it? Yeah, that's good. That's good. There's lots of events going on. I know lots of you are involved in events. We contribute to the funding of it along with the SPA, the RAS and the FAS. So the Federation of Astronomical Societies, the Society for Popular Astronomy and the Royal Astronomical Society. They all contribute to it. And it's a week of lots of different events going on. I can't remember, did I manage to get the map to copy on the next slide? They're all over the country. No, that's just one back. There's events even going on in Pipistock, Northern Ireland, way up in the Highlands and Islands of Scotland. So there's lots of things all over the country for people to come and see and do. Okay, next slide. Just to bring to your attention an upcoming meeting of the exoplanet subsection. This is Roger Dimmick's baby. He's got this running and involved, and he's holding a meeting on the 22nd of February. Thinking Day, that used to be, for those of you who were in the Scouts and Guides. Anyone remember Thinking Day? Total blank, right? Moving on. About being good. Callum has asked me, Callum Potter, director of the Sky section, has asked me to remind you of his meeting on the 22nd of March. in sunny Cheshire. And here's a list of speakers for you. You can just have a quick look on the website. It's got all the details of what people are talking about, so on and so forth. And what else have I put up there? I think there's another slide. Diane.
Apparently, I can only see the audience on Zoom, not yourself.
Oh, that's all right then. That must mean one of the cameras is not on.
I think we're just sharing the screen, Janice, and not.
Yeah.
All right, okay.
People will have to.
Now that makes sense. Okay, sorry to people in Zoom, you just see the screen. That's probably best. At the moment anyway. Okay, we have another BAA. Our next BAA meeting here in the Institute of Physics is on the 26th of March. Speakers still to be firmed up. We have a new chair of the Commission for Dark Skies, and we're hoping that he may be able to come along and share a few words with us. But I haven't had a confirmation from him yet on that. Okay. Next slide.
We're not sharing slides at the moment, so I'm just going to bring slide picture.
Yes, sir.
It says the roof lights across whatever slide does come up.
I think that's what you're trying to fix. You can just see the roof lights or
Oh,
something.
no, I think that's the lights in the room. So if someone wants to turn the lights, because they're glaring off the screen, I think, but we're not.
Yeah,
That's the.
1, 2, 3, 4, 5. Thank you, chaps.
Stands work.
Yeah.
Can you hear me?
Yeah, we just need to turn sharing on. If you can do that, if not, I'll come and help at the back.
In what do I turn it on? In Zoom or in
Zoom.
Probably. I don't want to share
There
one.
was lots of BAAs.
Yeah, yeah.
If you go to the.
Oh,
On the shelf.
we're sorting this out. My last slide
Yes.
is about the Winchester meeting. We still have some places left, but as you all know, all regular members, book early to get along to see it. It's always a really popular event. And of course, our Alfred Curtis lecture is going to be delivered this year by Dame Jocelyn Bell Burnett. Don't forget, Sunday afternoon is a special session for members to put on a demo or a presentation of stuff that they've been doing. And so you have to just let the organisers know that you would like a slot. And I'm very disappointed to say that Eric and Ernie are apparently not going to be doing a slot this year. I know, it's heartbreaking, it's difficult. So that's more time for everybody else. So that's more or less my welcome and in.
Andy, it's now good.
Thanks, Nick.
Are we all ready to go? Last slide, last
Hang on a
slide.
minute. We've got a different slide to what's on the scanner. Is it a different screen? Are we sharing a different screen?
Hopefully sharing
Okay.
screens. We'll find out in a minute.
Thank you.
No, you're not.
Okay, it's just so far. Right, then, thank you very much. I'm going to now start the speakers for this afternoon's meeting. Oh, one thing I have forgot is the paper secretary business. Sorry, Jeremy.
So we've actually had a bumper crop of papers approved by council at our meeting this morning. There are actually 5 of them. So let me read those out. All the papers, patterns in the initial System 3 longitudes of Saturn's Great White Spots 1876 to 2010 by Richard McKim. Spectroscopic study of 5 Mira stars by David Boyd. What was the comet depicted in Giotto's Adoration of the Magi
Yes.
by Mark Kidger? Noctilucent Cloud over Britain and Western Europe 2024 by Ken Kennedy. And the fifth one is An Ancient Observation of T. Coronae Borealis by Graham Shipley. Right, thank you.
Thank you, Jeremy. Sorry, I nearly missed you. I'm a bit frantic up here today. Okay, now I'd like to welcome a warm welcome to Sri Ramakrishnan. Yeah. Who is going to speak to us now on Sky for All, bringing the universe closer to young minds. Sri studied physics at St. Joseph's University in Bengaluru, Karnataka in India. And since coming to the UK, she's developed herself as a cosmic ambassador, visiting Kielder and the Royal Observatory at Greenwich. And she currently runs a business providing an after primary school club, teaching and getting people enthused about astronomy. Her talks about how she's personally introduced astronomy to children and some of the practical examples of how she's done this to spread the message. Let's give a warm welcome to Sri. Hi, my name is Sri, and I would like to introduce myself here that I recently joined BAA's Education and Outreach Committee, and I'm one of the cosmic ambassadors at the Royal Observatory Greenwich. And I also run a startup called Stellar Inspire, a dream come true, a dream for making astronomy and the wonders of the universe accessible for every child. When I was 11 years old, my dad, who's a school dropout and a bus driver, he was building something very tiny, and I was really amazed to see him. He was preparing for a solar eclipse. He made a small pinhole camera. Watching at the solar eclipse through that small device left me in an awe. This is really cool. That was the very first time I was looking at a solar eclipse through that small device, and I felt really amazed and felt like the universe is something that I could explore. But I grew up in a working class family in a small town in South India where opportunity and informations were very, very little, especially for girls. I decided I wanted to learn more, and reading beyond books or having something like an astronomical event, there was nothing beyond that for me. But this small incident of this solar eclipse, I felt like this is something that was driving me to the field of astronomy. Soon I became very interested in the field of science. I pursued bachelor's in physics, and later I did master's in physics. I was the first girl in my family to go to university and to pursue the path of science, where girls were expected to get married around 20 years old. But there are two incidents in which I can show you that my love towards astronomy became bigger. One is non-arrow.
Facebook.
Baseball.
No, I think it's.
Oh,
Yeah, yes, should be. It's just stuck in Zoom more than the
Right. So that was my first experience exploring astronomy. I was doing my bachelor's in physics. As an undergrad, I went to intern at OT radio telescope in India, where we had a basic set of massive radio telescopes, which was almost 530 meters long and 30 meters tall. There I learned about pulsars. That's the first time I'm experiencing something very scientific,
but I thoroughly enjoyed it. And later, when I did my master's in medical physics, I chose to do my dissertation in astrophysics, where I did my project at one of the world's highest optical telescopes, that's Indian Astronomical Observatory, under the protected dark skies in the Himalayan regions. And it was a wonderful experience, wonderful experience. Then I decided I wanted a telescope for my own. I wanted to buy one small, at least a small one. And but telescopes are expensive. I couldn't afford to buy one. I gathered some money, and along with my friend who is really passionate in astronomy, we pulled in some money and bought a small refractor and named her Nila. That's my telescope. It was a 70 telescope, through which I was watching at the moon for the first time. And I was mind blown by looking at the craters. And I even looked at the Jupiter's moon and Saturn's moon. And you can sense it, like, when you look at the moon for the very first time through the telescope, that feeling. I had it when I was looking at, through Nila. And Nila means moon in my language. But soon, I knew that I was interested in astronomy, but I didn't know how to pursue a career in it. Soon I got a scholarship and I stepped out of the country. I came to UK to pursue Masters in Medical Physics at the University of Surrey. I did really well in academics, but something was missing, the joy or the excitement that I had in astronomy, that was missing a lot. I wanted to connect back to astronomy, that, the love that I had towards astronomy. I started volunteering at a place called Kielder. How many of you heard about Kielder? So it was like a 10 hours journey from my place, but I enjoyed every bit of it. It was like a 2 days volunteering process there. I came back and I felt a sense of joy and a sense of purpose, which nothing else gave me. I felt like this is what I want to do. And for somebody like who has finished masters in medical physics and coming back to astronomy, I didn't know how to get this started. It was really difficult. I tried a lot of things. Like I tried connecting to a lot of professionals in astronomy in UK. I did even want to, pursue a PhD in physics. And I did some astronomy stalls, some astronomy birthday parties, and I gathered a small community in Blackheath to have astronomy sort of talk. I even went to House of Commons to watch UK Parliament committee meetings where I met David Oddity from. And that's the time I felt like I have to step into something to get this started. One of those experiences involved was in the stall that was in summer in one of the schools in southeast London, which is called John Ball School. I started thinking about I should step into something which is making sustainable effects in children. And I started my pilot project as an after-school program, an innovative and engaging way of bringing children together and doing it. And the very first time I got a massive response from children, and I felt like that's the same me when I was 11 years old with this passion of astronomy. When I did the first session with them, they came back to me, they told me that I want to learn more. I asked them, what do you want to learn? We can customize the sessions for you. They said, I want to learn about dark matters, dark energy, black holes. I was really like, wow, children of year 3 and 4, they know a lot. I felt like I found my purpose. I wanted to do this. And parents began asking me to keep this going. We did a lot in the after-school club, actually, like building hydraulic rockets. We even set some real-time telescope viewing of the recent comet A3, and we did look at the moon craters a lot. And I felt like I still are inspired with a big vision to make astronomy accessible for children and give them the right equipment to learn about it and bring in experts to give them the knowledge. And I couldn't do all of this by myself. It was not easy, but I had a lot of supporters. But before that, now I'm thrilled to say that we are completely booked for the next term. We have more than 50 students now, and we have another school who's interested to do it, and we're booked for the next term, and we're thinking to expand this to more schools in the future. Like I said, I couldn't do this all alone. I had a lot of astronomy experts with me to do it. And one of them is Helen Asher, who's sitting right at the back. She came with space rocks and she came with meteorites to, do a session and comets. It was really amazing. If people who don't know about Helen, she is the Director of Education and Outreach in BAA. And it was amazing. I was sitting as a student there and I felt that I am enjoying this class too. Likewise, we had a lot of other astronomers from Glasgow, from Cambridge, from London as well. I got all of them through connections, but they were really happy to come and help me with this pilot project. And it was a great success. There are two important and exciting projects that I would like to do in the future, and I would like to share. I'm looking for ideas, partners, and sponsors. Like, one of it is the Young Space Explorers Award. It's for inspiring young children, as well as bringing them together, getting them to do some projects related to science. And they can be from primary school or secondary school, and help them get some incentives. Winners get some incentives related to astronomy so that they can, pursue astronomy in the future. That's one of the projects that I'm thinking in the future. Another one is expanding astronomy to underserved societies, like a mobile astronomy club. But I need more ideas and thoughts on this, if anybody could help me here with that. So we basically want to make astronomy accessible for children in deprived areas, mobile astronomy clubs with equipped vans, setting up something like stargazing nights or workshops, or bringing them together to have connections in STEM and astronomy across the UK. So these are the two things that I'm looking for. And I am really fortunate for the incredible support of BAA and First Light Optics, who's given me really high quality telescopes to run my sessions. And without BAA, I feel like I wasn't having a starting point, but I felt like BAA gave me an initial point for me to start. And thank you for that. And I stand here as an adult with a lot of enthusiasm that I had when I was 11 years old. But not every child has had a dad like me to inspire me in this journey. But people in this room, or anybody who's listening to this online, if you think you can help us in this journey, maybe do a session online or maybe come to us, I would love to hear from you. And I know all of you are experts in one or the other way. I would love to hear from you. If you could scan this QR code and give your details, it comes to me, and I would love to hear what you would like to do in it. Yeah. I'll give a moment for you to maybe, if you'd like to do any sessions with us in the future. And it'll be really amazing. Our school children, they would really love to hear from you. You can do either online or offline. It's a 45-minute session, and they would love, I'm sure, like Helen and a lot of other astronomers who has come to teach. And thank you so much for letting me share this story. Thank you for the opportunity, David and James. Thank you. Thank you.
Has anyone any questions for Shri? Thank you very much for giving us the insight into what you've done in your past and how you're getting your connection going, your Inspire group and all what they're doing. There's a lot of people here who belong to all the different societies and clubs that are all doing these things too, and it'd be great that there's all linking in with each other of what goes on. So let's have, are there any questions from the floor? David. Yes.
So when you started doing your classes the first time or the first few times, are there any things that really surprised you about how it went, that you didn't know what would happen, and then you've learned? What have you learned about how to approach the kids, what they like to do, what kind of things get them engaged and get them actually learning and retaining the information, wanting more?
Yes. It's very important that we speak in their language, like how they can connect it to astronomy. Speaking about astronomy or space science in a higher level is going to be really hard for them to do. So always when I go to class, they would ask me if there's an activity for me to do. Is there anything special for me to do? Then what I thought, they would like to enjoy things online, like say, for example, setting up virtual telescopes. I was really amazed. I was thinking like they might not enjoy it, but Helen came and did the sessions with me. And I felt like there is a lot for students to learn online, and they are really keen to learn things online. They would like to do hands-on activities, but they would also enjoy something like online, setting up real-time telescopes and taking pictures of amazing comets. And yeah, I learned a lot from them. I was thinking what they expected, what I expected from them, and what I received from them is a massive difference. Like I said before, when I was asking them, what would you like to learn in the next class? They said dark energy, dark matter. So I was really amazed, like somebody who's this young knows about dark matter and dark energy. They wanted to pursue more. So it's really, for me also, it's a good learning when I go to each session. I feel like there's a lot to learn from everywhere. Yeah.
Thank you very much. Thank you. We don't start with the youngsters. They're never going to turn into ancient ones like some of the rest of us, are they? Right, let me introduce now.
We have a bit of a problem.
Oh dear. Wisdom.
I thought that the Zoom we were using was the BAA one, but I've been taken off the license, so the meeting's going to end in 8 minutes' time. So we're just trying to get the BAA license for Zoom so that we can transition over.
I think I have it on my Mac. That's right.
And it's just talking power.
Just talk amongst yourselves.
You can start with Tony. It just means that we'll have to do a break.
Because we're on a schedule. So you'll be here at tea time, won't you?
Yes.
Our next speaker, yes. Have you given them space bar or the Ladies and gentlemen, can I introduce Tony Cook, who is the director of the Lunar section? That was his father, actually, which tells me, is that right?
Yeah.
He was introduced by Patrick Moore to open Lunar, and he's going to talk to you today about an exciting lunar impact flash project that amateurs can participate in during the lead up to and during the Italian ESA lunar mission LUMIO in 2028. He videoed his first lunar impact flash almost a quarter of a century ago, now with an 8-inch Dobsonian perched on a colleague's balcony during the 2001 Leonid storm, with the moon low down near the horizon near Alexandria, Virginia in the USA. He also captured the first lunar impact flash on video from the UK on New Year's Day in 2017. Tony is a lecturer in physics at Aberystwyth University and co-investigator on the Italian ESA LUMIO mission, looking for lunar impact flashes on the lunar far side. And he has is creating an observing network monitoring lunar Earth times. Would that be right?
Right, yes.
Right. Oh, welcome.
Very difficult to follow the previous lecture, which was so inspiring. I don't know if you'll still be inspired at the end of my lecture, but here we go. Right. So the LUMIO mission, it's a, explain a little bit more about it later, but it's an Italian mission to the moon funded by the European Space Agency, due to fly, launch in about 2027, 2028. So today we're going to cover what is an impact flash on the moon, a little bit about the history of impact flashes, because they have been seen over the years, talk about the LUMIO mission itself, how can you and the people online, if you are able to watch, how can you take part in this program and produce some very valuable science for the scientists involved, and maybe even get your names on some publications. Talk a bit about the observing technique. I've set up a little website here. It's work in progress. It's a very basic stuff there at the moment, but over the next few days and weeks, I will populate that with detailed information for beginners, medium level observers and experts. Anyway, down the bottom, I'll show you that at the end. Also talk about some of the craters which form when impact flashes happen, how amateur astronomers, if they particularly want to, specialise and do things that even professionals can't do, and then we'll have a little summary at the end. Next slide, please. Right, apologies for the elephant down there. Just click on the, yeah, right, we'll get the net. Okay, right. On the Earth, or in the atmosphere, when a meteoroid comes flying through space at many kilometres per second, you experience the effects as a shooting star. Sometimes it's very bright, sometimes it's very faint. Next. But on the moon, there's no atmosphere, so it just goes, I won't try to hit this, it just goes whack onto the surface. And you get 4 things basically happening. You get a crater, all of a sudden appear in front of you, a hemispherical crater. Then you get ejector flying out, and then you get a flash of light, pretty much all at the same time. That flash of light is very, very brief. If you blink, if you were looking with your eyes, you might miss it. It's typically about less than 1/10 of a second. Some of the brighter ones can last a bit longer, but they're a little bit rarer. Quite a bit rarer. Next slide, please. Now, who knows what kinetic energy is and potential energy here? Put up your hands, just out of interest. Right, slightly over half of you. It's movement energy, whereas potential energy is stored energy. Now, if you imagine a harmless little paperclip, how can that possibly do you any harm? Tiny little thing, about 1 gram. 1 gram flying at a speed of 50 kilometers per second through space, which is perhaps slightly on the high end for some meteoroids in space. If that goes slam dunk into the moon, that's going to release kinetic energy of 1.25 million joules of energy, which is a huge amount of energy. To tell you what it's like, if we can have the next one, please. It's enough to lift one of the heaviest elephants in the world 12 meters up into the air on the Earth. If you're on the moon, it goes up to about 72 meters into the air. That tiny little paperclip, it's a huge amount of energy. Next one, please. There goes the elephant. Right. Yeah, so it's that we're trying to detect from the Earth, a tiny, small amount of energy. Huge amount of energy, actually, but it's only about less than 1% of that, perhaps even 1/10%, which gets converted into light, and we can see that from telescopes here on the Earth. And that proportion there, that less than 1%, is called the luminous efficiency. It's how much of that energy gets massive display, many thousands of meteors per hour. It's actually over 2 or 3 years, it's over. And they predicted on this particular occasion that these meteoroids would be slamming into the moon at 75 kilometers per second. And might be worth astronomers possibly having a look. Doubtful if they'd see anything, but you know, they might. It's worth a go. They'd have to wait 33 years for the next one. And sure enough, the International Astronomical Timing Association, IOTA, got some observers to video of the moon, and this is the first time that we have video evidence of proper scientific evidence of impacts on the moon. We know it's not an aircraft because there were 2 or more observers looking at the moon at the same time with cameras, and they saw these flashes in exactly the same place. And that was revolutionary because I was told by astronomers, you never see meteoroids hitting other planets, you never see comets hitting Jupiter in your lifetime or over many centuries. It just doesn't happen. It's such a rare event. But there you go, it's happening. These things are reasonably faint, about magnitude, I think the brightest was about magnitude 6, and the faintest was about magnitude 8. Next slide, please. Thank you. Right, so why bother sending a spacecraft to the moon if we can see these flashes from the Earth? Well, actually, they're going to send this spacecraft to the far side of the moon. I'll explain a bit more about that later. And because it's a lot closer to the moon, the flashes are going to be brighter due to the inverse square law. Don't worry about that, but the closer you are to a light bulb going on and off very quickly, the brighter it is. So you should see a lot more flashes and be able to do a lot more statistics and science. There's also, on the far side of the moon, we don't see any light from the Earth illuminating the moon. You can see the night side of the moon from the Earth simply because, on the moon from the Earth, simply because the reflected light from the Earth illuminates the dark side. That is very pretty to look at, and it helps you to locate things easily, but it adds a bit of noise. So going to the far side photograph impact flashes will allow you to go a bit fainter and get better statistics. Now, they're interested in this for another reason as well, in that there may be a difference in rates of things hitting the far side and the near side. We're going to learn a little bit more about that from the directions of meteoroid streams. Next slide, please. Okay, give it another go. Yeah, difficult to do things in the dark. Anyway, this is the Italian mission, LUMIO. It's going to launch from the Earth, take a little while to get to the moon, going to decelerate. It's about 140 days to get there, and it's going to decelerate and go into an orbit about one of these Lagrangian gravity balancing points. It's not going to orbit around the moon, it's going to orbit around the gravitational balancing point. These are quite useful things to go into orbit around. We have some satellites up there already doing that. So the advantage is it's going to be viewing the far side of the moon all the time. It's going to be able to obtain full disk images of the moon. The Earth, because it's away from the Lagrange point, it's always going to be able to in contact with the Earth, and so on. Because of the orbital dynamics, it's not going to always be at the same distance. It can vary from 35,000 kilometers to 85,000 kilometers. But anyway, it's going to be quite a very, very interesting mission. Right, I'll just go on. Yeah. Okay. Right, so what are the restrictions of observing from the ground? Well, I do really want to encourage you to go out and look for impact flashes from the ground. Well, first of all, you can only do it during a night on the Earth, and only when the moon's above the horizon, and only when the moon is approximately 10 to about, I would actually say about 65% illuminated, because after that there's too much glare from the bright side. Also, the types of meteor streams, the apex and antipex sources are detectable, so that it's a bit constrained what meteor showers we can see. We can't always see the full disk because of stray light, and we have the effects of Earthshine. Of course, we have the lovely weather, don't we? Preventing us from observing most of the time. And as the moon sinks down, there's more atmosphere in the way, so that you lose your sensitivity. The spacecraft bypasses all of that. It also gives you 15 days uninterrupted observations of the far side. We can't do that from here on the Earth unless you have a worldwide distribution of observers. You can start to look at the anti-Helian sources of meteoroids, toroidal sources, and when you are detecting impact flashes near the limb of the moon, you may be able to see them from the Earth and from the spacecraft at the same time. We could have simultaneous observations from different sides of the moon, maybe even do some 3D geometry. Next slide, please. Oh, not working for me now. There you go. Right. This is the number of impacts they're expecting to be, because they're closer to the moon. The flashes are brighter. So it can be anywhere from about 50 per day up to maybe as high as 500 per day during the Geminids. So they get variation of the flux rate, the number of detections per day, as seen from the spacecraft. It also is going to vary with the illumination. Perhaps I'll lose a tiny bit of sensitivity the more illuminated the moon is, but not as badly as we have from the Earth. And that shows you some of the showers they're expecting to get up there. Brilliant. This is a lovely camera flying. The mission is actually a CubeSat mission, fairly small mission, low cost, and they've got 12 units bolted together, and the total mass for this particular camera is about 3 kilograms. So there you've got the camera, it's got daffles on it, it's going to look at roughly the whole of it's going to get a hold of the moon's disk in, and at the back end of the camera, it's a kind of refracting system, it's just with lenses. There's a beam splitter, it sends some of the light that way, about half of it, and the other half goes up that way. It's called a dichroic cube, it splits the light 50-50. And they're going to put a camera at both sides over there, so that they will be actually observing the moon in 2 filter colors, one at about 450 nanometers, that's kind of a lighter shade of blue, and one in the near infrared at about 950. And I'll explain why they're going to do that later, but they're doing it in 2 wavebands simultaneously. Actually, I'll tell you a little bit about why they're doing that now. Sometimes with, or quite often with, when we're looking for impact flashes, we get false or fake impact flashes due to cosmic rays striking the CCD camera, or the air shower coming down through our atmosphere from a cosmic ray. And there's radiation in space as well. When you get a high energy particle hitting the camera, it can also look like a flash. So having 2 cameras observing the moon simultaneously, if you see it in one but not in the other, you can say, aha, that's a bit of radiation. But if you see a flash at the same location of the moon from both cameras, you know it's the real thing.
Just a quick question.
Yeah.
As you're talking about 2 cameras, have you ever experimented with using as big a baseline as you can with 2 cameras and getting some form of stereo photography?
You can do that. It will bring out the curvature of the moon, but it's really not so good for picking up the actual depths in the craters. You need to have quite a big topographic range on the moon to do stereo from one side of the Earth to the other to produce topographic maps of the moon. I have looked into that for...
You have looked into it?
Yeah. Okay, next slide, please. Right, the really interesting thing is why we're using 2 wavebands is you can actually measure the temperatures of these flashes. It's a little bit like the stars. The hotter the star, the shorter the wavelength. So if you've got something like the sun at 6,000, it's about yellow in colour. If you cool it to about 5,000 Kelvin, it goes into the red. If you cool it further, the 4,000 Kelvin, it goes into the near infrared. If it gets really hot, 10,000, 40,000, it goes blue. Hot is blue to do with stars. It's a similar thing on the moon. If you have a lump of material heating up, the hotter it gets, the more it goes into the blue part of the spectrum, and the cooler it is, the redder it becomes. These curves here are defined by equations. Don't worry about this horrible equation, the Planck function. But the important thing is, if you just get 2 points measured, the magnitude in 2 wave bands, you can decide which temperature curve you're on and determine the temperature of the impact flash. And this was pioneered in an observatory in Greece. They ran it for a few years until the money ran out. And this over here is a histogram showing you the range of temperatures. This is the frequency up here, and this is the range of temperatures they were detecting. So you can see a lot of them are peaking about 2,500 and 3,000 Kelvin, a bit cooler than the sun. This is where the sun is over here. So this is why they've got 2 filters on board. They can measure the temperatures of those impact flashes. Next slide, please. Right, okay. Work which is currently going on. Professional astronomers are very interested in this, and in the United States, the National Marshall Space Flight Center, they're all trying to observe as much as they can with 35 centimeter telescopes, a few bigger, and they're detecting roughly about 1 meteor every 5 to 14 hours, and a bit more frequently during proper meteor showers. In Greece, they had a bigger telescope, so aperture counts here. They had a 1.2 meter telescope detecting 1 every 2 hours. Now, how can amateurs compete? Well, there's a lot more of you out here. I'm seeing a lot more of you here than there are professional telescopes looking for impact flashes on the moon. You've got a lot more free time. The key thing is we can get your results if you send them in and combine them and produce an average and look at the errors on there and produce potentially better results than the professionals can do if we get enough results in. In Britain, we just view the moon when it's around, but there's a lot of BAA members abroad, so we can have coverage around the world and maybe not quite get 24-hour coverage of the moon, but get pretty good coverage. We can also, because we're very innovative, we can investigate new techniques like thermal imaging the moon, shortwave infrared, look at spectra, see if there's any radio emissions from these things. And one of the most important things is you don't have any research funding constraints. You don't have to apply for research funds to carry on studying things. So that's good. So when should you look for impact flashes? Basically between new moon and when it's 65% illuminated. That's in the evening or in the morning. No point observing during the daytime unless you've got a really special camera, but I usually find 10 minutes after civil twilight ends or 10 minutes before it begins in the morning. That's when the moon and the earthshine are fairly visible. Right, next slide, please. Okay, what do you need to do to go out there? Is it really specialised? Fortunately, it's not. All you need is a telescope. I put a 20 centimetre down because that's what I started with, but some people use smaller, other people use bigger telescopes that collects more photons, but whatever you've got really will do. I've heard it said that refractors can actually work a little bit better because they don't have diffraction effects and scattering off of the holder for the secondary mirror. If you're using an SCT, they're fairly big F number, so it's recommended to use a focal reducer in there to reduce the focal length and get more of the moon in. The more of the moon you get, the dark part, not the bright part, the more chance you will detect impact flashes. Most amateurs have cameras like these ZWO ASI cameras, and that's all you need. As long as you can have it running at about 10, ideally 25, 30, and if possible 60 frames per second, you can get brilliant results with this. And you've also got to be able to produce images of the night side of the moon like that in a single one of those exposures, and ideally pick up 10th magnitude stars. Most of those cameras will do that for you. Now you can work in white light, that's great, we'll be very happy with that, but if you can specialise by putting in a red filter or a photometric filter, RGB is used for colour imaging. If you use a photometric filter like a VBRI filter used for photometry of stars, that's also super if you can do that. But don't be intimidated. White light observations are fine. We would be happy to get those. We can still do a lot of science with those. It's not just if you find an impact flash, we want to know when you're looking, when you start and when you end. If you didn't see anything, that's fine, let us know, because that tells us what the flux rate is, how many meteors per hour are being detected on the moon. Relatively simple to make the observations. And most of you have got the equipment needed for this. Next slide, please. When to look. I have a website up here, Aberystwyth University. You click on that and it tells you, for example, there the next observing opportunity is going to be in the morning on January the 22nd between 5 and 6:56. I think this is for London. And there's another one opportunity on the 1st of February and a few more after that. That website, you can find your location on there or the nearest location to you and click on that and it'll tell you when to go out and observe. If there's a meteor shower on, it'll tell you as well about that. Okay, next slide, please. Right, now, as you can imagine, trying to detect a very faint flash of light lasting 1/10 of a second on video by watching it is probably doomed to failure 50% of the time because your eyes will be shut when you blink. Believe me, I've tried it. I've run it through in slow motion, that's one way to do it, but you still take a long time to look. A far better way is to use some software. So this is the first one produced. This is called Lunar Scan. It was available on this website over here. However, last time I looked, it wasn't. Now, if you are having problems trying to locate this, you send me an email, I will see what I can do for you. I won't say any more than that. But the good thing is, you can feed your AVI video in, and it'll look through that, trying to find impact flashes and output them for you. It's also got a prediction of where to look on the moon. So here is a picture for the Geminids. It shows you where to look on one particular side of the moon. So don't bother over here. Make sure your telescope's pointing over that area to pick up the Geminids. Okay, next slide, please. This is my own bit of software. It's not as nice as Lunar Scan, but it is readily available from that website over there. What you do, I'll explain in a minute. You take your AVI file from your video, you feed it to a program called Virtual Dove, which is free, and that produces a whole load of bitmap images, BMP files. We have those for images, and then you run the program. It'll look for impact flashes. So it tries to find bright pixels, which are so many standard deviations above the neighboring pixels in around it, and it also looks in the time domain, looking at one image after the other, a particular location, trying to find where one particular pixel in time is a lot brighter than its neighbours. And you can, if you want to, you can vary some of the parameters in there. I've got a handbook to help you, but I would leave it alone if I were you, unless you want to try some experiments. But anyway, what it does is it puts a box around the flash and it shows you at the top there where the flash is with those that time sequence along the top. Okay, next slide, please. This is a flow chart. Don't worry about it too much. There's your AVI video. You put it into this free piece of software called Virtual Dove. Produces a whole load of bitmap images in a directory. You run Alfie, and it outputs where it thinks the flash has occurred. It also does a data file telling you the frame that the flash is on, its location, some statistics about it. And if you particularly want to, you can feed it into Excel, Microsoft Excel, plot a graph, and try to work out what a real flash is or what are cosmic rays. Next slide, please. Here's another bit of software, a new kid on the block. This is called the flash detection software from Greece, from the people at the Neliota Observatory. And the good thing about this one, it's the only bit of software out of those three that you can run directly on the telescope, and it'll tell you instantly at the telescope if you've got an impact flash. Unfortunately, I've heard that it crashes occasionally, so be aware of that. And also, I've heard that the Y coordinates of the locations of the flashes is also sometimes wrong. But it's a third bit of software, and I often run my impact videos through three pieces of software because they're not perfect. No software is perfect. So running it through three, you get the best of all three worlds and hopefully come up with some reliable measurements. It also will try to fit the limb of the moon and the features of the Earth, trying to give you the coordinates of the impact flash that you see. Next slide, please. But beware, there's a lot of tricksters out there which will trick the software, and sometimes you as well, into thinking you've got an impact flash when it isn't. For example, you might get a cosmic ray. Usually they are not streaks like that, but they are 2 points of light which appear at the same time. So anytime you get a detection with 2 points of light, you know that's probably a cosmic ray shower event. Sometimes you get 3 or more occurring on there. Mountain peaks are particularly nasty things. They scintillate and they flash on and off, and that tricks the software sometimes. And then stars on the limb of the moon about to be occulted, they will also scintillate and trick the software. This is a genuine Lunar impact flash I recorded in 2001. You can see it wraps up bright, very, very quickly in brightness, then fades over time. You also get aircraft as well, helicopters, birds, they can also be detected. Next slide, please. Right, what about if you detect an impact, what about actually finding the crater? Now, this is probably not for the amateur astronomer, it's more for professional planetary scientists, but I had a PhD student, Daniel Sherwood, who completed his PhD. And he went out to OCA in France at Nice, and he was observing in white light, he was observing, and at the same time, some couple of Italian observers were observing from Italy. Antonella and Sonata over there, and they also videoed this impact flash, and it's quite a bright one. You can see it wraps up in brightness, and then this is over many frames here, and then it fades like that. Anyway, by getting lots of observations, by in this case 3 observers, Daniel was able to figure out the longitude and the latitude of this, or a range of longitudes and latitudes, and then he went to lunar reconnaissance orbiter pictures of the moon, which are about 1 meter per pixel, really high resolution. And what he does is he takes images which were taken in the past before the impact flash and images taken after the impact flash, could be many months afterwards. He puts them together in the computer, divides one into the other, and you get this. That clearly shows the crater, but it's also got the ejector pattern, the material thrown out. And he uses that sometimes, even if he can't see the crater, it's in a neighbouring image, to home in on where the impact is. And yeah, so that was published, and the amateur astronomers got their names into this monthly notice of the Royal Astronomical Society paper. So I'm not promising you that if you detect an impact flash, we will put you into there, but if it's a particularly special one, you will probably fairly likely at least receive an acknowledgement and maybe end up as authors on the paper. Right, next slide, please. Oops. There we go. Right. Here's another close-up of the impact crater. It was seen from the NASA Marshall Space Flight Center back in, let me see, it was 2013. It was a very bright one. This is 4th magnitude. You could even see it with your eyes if you had been looking at the moon at that time. But anyway, they got some NASA images, and these are the before and after images, and you can clearly see that crater there. In this case, it reached a diameter of about 19 meters across that crater. And but the important thing, of course, is the ejector. As you can see here, that goes over many, many kilometers radially. If the object had been coming into an angle, then the ejector pattern would not be radial, it'd be more in a particular direction away from the impact site. The importance of this is when they return to the moon, and they are starting to return to the moon, if you see an impact flash near a potential landing site for a rover, this would be a really good opportunity to send that rover over and have a look at a fresh impact crater and examine it before it starts to become space weathered and degrade over time. Might even find some volatile like there from the original impactor, or perhaps percolating up from underneath the moon's surface. Okay, next slide, please. Brilliant. So what is it possible? How can we specialize in amateurs? Well, the most important one is if a lot of people video an impact flash at the same time, we can put all their observations together and work out an average. Here is impact flash light curve observed from Spain, 2000 8, and shows a rapid rise and an exponential decay. But there's lots of little bumps in there which are interesting. Are they due to scintillation in our atmosphere, or is there something really going on the moon's surface? Dust clouds getting in the way, blocking the light? We don't know. We just got a snapshot view. But if we get lots of amateurs together and average the light curves, if it's due to the atmosphere, we can smooth it out, and we'll start to see real features in there which will help scientists improve their computer models of how impact flashes should appear. Next slide, please. Okay, this is even more specialist stuff. So this is the one that was seen from the UK. I should state that I did not discover this. I videoed it, and then being an academic, I sat on my data because unfortunately I have to do academic things like teaching, and it was several months. And then I heard about an observer in Switzerland who was also observing then and detected a flash on the moon. I checked my video, and that is a cycling loop of that flash over there. That's the first one videoed from the UK. Now, the interesting thing about that is, as you can see, it's got a shape to it. And we checked with the observer in Switzerland, and there they also had a similar shape, and the orientation is in the same direction from a different geographical location. So it's possible that one might be caused by a meteoroid coming into an angle and the ejector going out over a few kilometers, and that's why it's elongated. Alternatively, it was maybe bright enough and it illuminated some nearby mountains, maybe a kilometre or two away, and that caused the elongation. We don't know, but we're on the lookout for things like that. The second one over here, this was also observed from Switzerland. This is the only occasion we've seen of ejector coming off and being illuminated by sunlight. Unfortunately, we only have one observation of this. It would be better if there were two, but papers have been published about this, and we think it's a genuine impact and ejector coming off into sunlight. Some of that stuff is going faster than the escape velocity of the moon, and it won't come back. Then over here, Daniel Sherwood, my PhD student, he got a shortwave infrared camera which works in the J band, which, if I remember right, is about 1 micron to about 1.4 microns, or maybe 1.2 to 1.4. But going to longer wavelengths, the impact flashes actually last longer. And the other good thing is there's less scattered light from the moon, and you can even observe in daylight, because the brightness of the sky, due to Rayleigh scattering, the blueness of the sky isn't there the further you go into the infrared. And he reckons, this was observed at dusk, but he reckons that you could actually observe some of the brighter impact flashes during the daytime, extending the coverage of the moon. Next slide, please. And some really speculative things here, which I'm investigating. We can work in the thermal infrared, even further into the infrared. I've got a camera here. You can buy them, put them on mobile phones. One has been talked about in the BA journal from the instruments section. What I've done is I've taken this thing which fits on a mobile phone. You've got a USB extender cable. I've taken the lens off of it, and I've put a thermal infrared window in there. I put that directly on the telescope, and I can obtain video of the moon in the thermal infrared. But you must work with Newtonian telescopes. It won't work with refractors or SCTs because glass gets in the way, and glass is visually opaque. So what we would expect to see, I'm going to show you if you just click on the slide, please. That's an optical picture, and that's a thermal infrared picture. The resolution's a lot worse. There's a lot more noise, so it's difficult. But if there was a really big impact on the night side, the heat from that would dissipate and then start to peak in this region in the thermal infrared, which can detect temperatures about -40 to +330 degrees C. Another technique, which I'm investigating, is polarimetric imaging of the moon. You can buy chips now which have got polarized filters on them in 4 different orientations. And that's a white light view of Censorinus crater on the moon. This is a map of the angle of the polarization. That's the degree of polarization. Now you might think, what's all this for? When you get an ejector pattern like rays, it changes the polarization angle, and they are there permanently after an impact. So if you've got before and after images, you may be able to detect something. Secondly, if you get a dust cloud, that can also change the degree of polarization. So this may be a technique to use on the daytime. And then finally, the early days of the Leonids, when impact flashes were first being detected, people were attempting radio monitoring of the moon to see if they could detect some piezoelectric discharges, and they were working at about 13 centimeters. The results were inconclusive, but it could be worth maybe the radio astronomy section looking into this with observers distributed across the UK to see if you can pick up something which coincides with sightings of visible impact flashes. So next slide, please. So just to finish, it's actually, may not look it, but it's actually easy to observe impact flashes. You need camera capable of going down to 10th magnitude, working at least 10 frames per second or faster if possible. Inside cameras are good. If you want to have a cheap route in, you can buy cameras for 20 to 50 quid on eBay, Autic 902Hs. They produce analog video, which you can feed into a USB video digitizing device and put onto your computer. Software to detect flashes, there's that one in Greece. There's my Alfie software, or I can let you know about the Lunar scan software. Remember, professional astronomers are limited in time and resources. You have a lot more free time. Where to look, that's the website for that. So in 2027, 2028, LUMIO will be launched and it will look for impact flashes on the far side, but we need to compare rates on the near side and the far side. So far from the UK, there's only one confirmed impact flash which has been detected. And just one last thing, you are approximately 150 times more likely to detect an impact flash on the moon than you are in Jupiter. Not that you should stop observing Jupiter, that is really important that you do that. But I'm just saying the chance of detecting an impact on another planetary body is at least 150 times more likely on the moon. So if you're interested in impact flash observing, you can contact me over there. That's my email address. Or you can go to that website again down the bottom and I can provide you with more details. Oh, and lastly, if you want a book, it's a little bit out of date, but it's still, I think, available. There's a book by Brian Cudnick over there, Lunar Meteoroid Impacts and How to Observe Them. You can buy that on Amazon. Thank you. Are there any questions at all?
Any questions? Let's see. David Grist, back of the room first.
Yeah, I was intrigued when you said there might be a difference between the impact rates on the near side and the far side. And I'm struggling to get my head around why that would be.
Right, well, the Earth's going around the sun and the moon's going around the Earth. So you've got all very slight, small differences to the meteoroid velocities, which are obviously bigger than the Earth's velocity around the sun, and particularly the moon, which is only going around at 1 kilometre per second. But it does have an effect with that kinetic energy equation, because a change in velocity, if you double the velocity, you quadruple the energy. So we would expect to see perhaps differences between the near side and the far side. And secondly, there are directions in space where meteoroids are more likely to come from for sporadics and so on. So we might expect to see something there.
Would that not be counteracted, say, 2 weeks later? When the Earth is...
It may be around the other way. You may be seeing slightly less,
Yeah.
perhaps, as well. So that's what they're going to look for, to see if there are any differences.
You had a question.
You drew up a brilliant example of lifting an elephant 72 meters off the surface of the moon.
Right.
Flat Earthers love that one. But in one meeting in the pub after some event, and some of the people I was meeting with are probably in this room at the moment, we were speculating how visible a large nuclear fusion bomb, H-bomb, would be. Let's say 10 megatons, even 50 megatons is the biggest. If that exploded on the moon, how visible would it be for how long? How does it compare with some of your impacts?
Ooh, that's a good question. Without remembering
Pints of beer would help with that one.
the megajoules for nuclear bombs, I would imagine that it probably would be quite visible.
So Tony, in one of your earlier slides, I was going to ask actually, because they used units of kilotons for energy release.
Yeah.
And they were this was for the LUMIO thing, they were fairly small fractions of a kiloton.
Right.
So I imagine megatons would be bloody bright,
Yes.
I'm guessing.
Well, Russians could do something useful.
A question from David and then from Philip.
So how many have been detected by emitters?
Right. I would guess probably about 20 or 30 compared to professionals which have done a few hundred.
That doesn't correspond very well with the 150 times the rate you'd expect on Jupiter, because amateurs have seen at least 10 flashes on Jupiter, so you'd expect thousands on the moon. So why is that? Is that we were just ignoring the moon? It's so familiar, we're not trying.
Yeah, there's not many people out there looking at the moon, and we get weather problems as well. And another annoying thing is in the past they haven't recorded the number of hours they've actually been looking. They just put up, yeah, we got an impact, but they don't record the start and the end. And that's something I want to correct with people sending observations in. Even if you don't see anything, I'd like to know how long you're looking for, when you started, when you finished observing. Because if somebody else detected something when you were observing, you didn't detect it, we can go back and examine the video and see if is anything there.
So lots of people doing full disk observations of Jupiter, but not many doing full disk observations of the moon.
Yes, and it's not even a full disk, it's about half the disk you're looking at. Yeah.
Philip, you had a question?
Yes, fascinating talk. Thank you very much. There's a lot of talk at the moment about the scope for smart telescopes like the Sea Star, for amateur monitoring of transient episodes. So, for example, variable stars that you can get observations using very similar setups of the same event. Is that applicable for lunar impact?
It might be. I'm just looking at the size of the apertures. They're a little bit on the small side, but I would never say never. I'd say give it a go and see what we can do with that.
Thank you.
There's an online question, Dennis, as well.
Where?
Read it.
Yeah, James Dawson says, can Tony please share a link to the lunar scan detection software? As you said, the current link doesn't work and no Googling comes up with any links. So
I think the most diplomatic thing is if he emailed me.
is it really that way? It's not something that's kind of available.
It's software which was written by somebody who works for an IT company in the States, and it was given to NASA. And I think we have to be a little bit careful about software which isn't available anymore out there, not from the vulnerability of the software, but over, sort of ownership and stuff like that. I would probably contact the people in the States to say, I have a copy which I have from the past, and could I please send it to all these observers?
Okay, it's very diplomatic answer.
Thank you.
Gentleman at the back.
What are all the things they can look for in a fresh crater?
What are all the things they can look for
in
that?
a fresh crater.
In a fresh
crater. I was going to just refer to that because it would be fantastic if we had a rover there.
Yeah.
At the right time, at the right time.
Over time, craters degrade. They get hit by micrometeoroids and they rock shatter and become smaller and smaller. There may be evidence of the volatiles present in the meteoroid. Maybe even some of the meteoroid itself could be embedded in the crater somewhere. A lot of it is melted. Craters gradually shallow over time by dust flowing in and by the rocks uncompressing. So there's quite a few things they could study. So if you happen to have a landing site and you happen to have an impact flash seen nearby, why not send the rover over to see it? That's my argument anyway. And I think a lot of people on these planning missions to rovers would probably agree with that. It's a great opportunity for doing new science.
Thank you very much, Tony. I know you've got a train to catch, but are you going to be around for tea break?
Maybe for a few minutes.
Or anybody else who's any other questions? And it sounds like a great project for people.
Yeah, I would really love as many people here to try to at least
Beginners
give it a
and
go.
even
Give it a
people
go.
further along the line, yeah?
That's right.
Excellent. Well, thank you so very much for coming along today and giving us your time, all the way from Wales up at 5 this morning. You said. All right, let's show our. Here, it's tea time now because it's getting a bit warm. So I think we need some refreshments of that. Okay, so Jeremy, director of the variable star section, combines his interest in the history of amateur astronomy with variable stars, and he's combining these specifically in this talk this afternoon. He's a past president, known to many of you, of course, and is currently, still hopes so for a long time, paper secretary. So a warm welcome from Jeremy.
Thank you very much, Janice. Do we have the lights down? I think that proved better for the people. There are people watching online and the lights disturbed otherwise. So thank you very much for the kind introduction. Thanks everybody for coming today. So novae. So I think it's fair to say, as far as we know, since the dawn of history, the appearance of a new star or a nova in the night sky has caused all kinds of wonders, excitement, sometimes fear and awe. And it used to be thought that these are one-off events, a nova would appear and it would never appear again. But we now know that, or it's now thought, that most novae do reappear on some time scale. It could be thousands of years or even tens of thousands of years. Now, there are 10 known recurrent novae in our galaxy, so ones that have been observed to erupt more than once. And this afternoon, I'm going to be speaking about one of those that's in the news a lot at the moment, which is T. Coronae Borealis, or T. Cor Bor. This is really on the top of the list of many astronomers around the world. So as soon as this goes into eruption, astronomers have already programmed in observing sessions with optical telescopes on the Earth, satellites at all kinds of wavelengths, with radio observations. So when this happens, it's going to be a really big event. And there are people observing this star roughly on average once every 6 minutes. So we hope that it will be. It's absolutely critical because it's in those early phases of a nova eruption do we stand to learn most about the astrophysics of these fascinating objects. So this afternoon, I really want to concentrate on the last eruption that took place in 1946. This was very poorly observed. In fact, in the first few hours, there were only 3 observers, and there were a number of reasons for that. The first reason is people didn't really expect T. Coronae Borealis to erupt. It had erupted previously in 1866, but there was really no reason why it would go off again. So people weren't looking out for it. The second reason is that when it did go off, it was really poorly placed in the February night sky. So there weren't many people observing it. And the third reason is that this is February 1946 when it erupted. And of course, that's only a few months after the end of the Second World War. So many observers were still away on active service, some just returning to civilian life. But of course, there was massive disruption around the world. So let's look at those eruptions in the eruption in 1946. But before I do that, I think we ought to ground ourselves on what a nova is, or what T. Coronae Borealis is. It's an example of a symbiotic nova, and it comprises 2 stars. So it's a binary star system. In the center of it, you can see here is a white dwarf, and that's almost the mass of the sun. And it's being orbited by this red giant star. And that goes round the white dwarf once every roughly 227 days. There's a third thing you need to know about, and that the outer layers of this red giant star are being sloughed off or lost into space. So there's a nebula that surrounds both stars. So the stars are interacting. And because the white dwarf has a very high gravitational potential, it's sucking gas off this red giant. It goes around an accretion disk, that's the murky area here, and ends up on the surface of the white dwarf. And it will accumulate on the surface of the white dwarf until it reaches a critical point. And that critical point, when the density and temperature are sufficiently high, instantaneously, it will trigger a thermonuclear reaction. So that is what we observe as the nova outburst. So I have a little video of these 2 stars. You'll see the large one rotating around the white dwarf, and you'll see some activity. You'll see the activity on the surface of the red giant star. There's star spots on there and other active regions. Just bear in mind the distance of these two stars, well, that the star system would fit in, say, just between the orbits of Mercury and Venus. So that's how far apart the two stars are. So if we play the video, so we're going round behind the back of the red giant now. You can see all sorts of gas coming off. Oh, there's the white dwarf coming into view. There's the accretion disk of all this gas and matter around the white dwarf, spiraling in, accumulating on the surface of the white dwarf. We've gone now back, further out. You can see the stars rotating. That's all the matter around the system, and that was the nova eruption. So that was the thermonuclear explosion. And gas is blasted off the surface of the white dwarf into space, and you will end up with a gaseous cloud around the system. That can be seen around many novae, but one hasn't been, as far as I know, observed around T Coronae Borealis. But there is gas around it. Now, it's important to bear in mind only a very small fraction of mass of this system is lost in the eruption, and for that reason, it can undergo multiple eruptions. So it's not blowing itself apart completely. It's only a little bit that's being lost in the process. So the other thing to know about this system is, I mentioned the very high gravity of the white dwarf. Well, that is so strong, it's actually distorting the shape of the red giant star. It's making it into a pear-shaped object, so a slightly elliptical object. As you can see here, you can see it slightly elliptical there, and as the system rotates, you see it circular and then elliptical and circular again. And we can actually see that if we measure the light levels of the curve over many days. And you can see the light curve here, and you can see it peaks every 227 days, and that's the orbital period of this system. And those peaks and humps, you'll see more of these later, are quite large. They're about 0.3 of a magnitude, so they're easily detectable by visual observers as well. So that's something to bear in mind that, in terms of the ongoing variations of this object. So the 1946 eruption, the first three discoverers of that were amateur astronomers. And it so happened that the previous one in 1886 was also detected by an amateur astronomer, this gentleman here, John Birmingham, who lived in the west of Ireland in County Galway. He was a keen amateur astronomer. He wrote a column in the local newspaper, so he was known for his astronomical interests. And one evening, on the 12th of May 1866, he was coming home late. I don't know where he was coming home late from, but he was coming home late just before midnight. And he looked up in the sky and he noticed T Coronae Borealis, or he just saw a star that was out of place next to Coronae Borealis, the northern crown. And because he knew the sky well, because he was an amateur astronomer, he immediately knew it was a new star, a nova. And he caught it at its maximum, or near its maximum of magnitude 2. And when he observed it, this is where he made his fundamental error, because he wanted to report the eruption to somebody so other people could observe it. But rather than contacting the observatories in, I don't know, Dunsink or Armagh or Greenwich, he wrote a letter to the Times of London, which took some time to get there. And he writes later how he imagines it arrived on the editor's desks. This unknown guy from west of Ireland finds this new star straight in the waste paper bin. So what he decided to do was write to somebody else. And the somebody else was really quite an important and sensible person to write to. And that was William Huggins, who lived in London. He was a pioneer of spectroscopy. So he wrote a letter to Huggins that arrived on the 16th of May, so a few days after the discovery. Now, it so happens that another amateur astronomer had observed the eruption on May the 15th. A very prominent amateur astronomer from Lancaster called Joseph Baxendale. And he also wrote to Huggins. And bizarrely enough, both their letters arrived on Huggins' desk in the same mail. So he thought there must be something going on here. As soon as it got dark, Huggins went out to his telescopes and took the spectrum. The spectrum is shown here. This is the first spectrum ever of a nova in eruption. And Huggins described it the following day at the Royal Astronomical Society meeting in London as looking like a star on fire. And it has this, what at the time was a bizarre spectrum where it has the dark absorption lines like you would see in the sun spectrum, the solar spectrum, but also at the same time these brighter emission lines. And it was immediately known that there was lots of astrophysics to be determined from this first spectroscopically observed nova. So after that, the system, well, everybody forgot about it for many decades, except for one person. And that one person is the famous American amateur astronomer called Leslie Peltier. Now, Leslie Peltier wrote a fantastic autobiography that I'm sure many of you will have read. I've got multiple copies at home because it's my favourite book. I read it once a year on holiday. It's also the book that got me through English literature O-level because I couldn't finish The Mayor of Casterbridge. I'm a very, very slow reader, and I was allowed to choose any book on my own. So I chose this one. And what Peltier got in his mind, having seen a nova, is that, well, perhaps they do come back once in a while. So he began to look at this star every clear night since 1920. And he actually describes what happened. If I may read a bit of his book, because I love the way he writes as well. It's a really engaging writing. Let's assume it's light enough for me to read if I go to the screen. So he says, from 1920 onwards, I watched it closely at every opportunity. For more than 25 years, I looked on it from night to night as it tossed and turns in its fitful slumber. It was varying slightly, but it was hence a fitful slumber. Then one night in February 1946, it stirred, slowly opened its eyes, then quickly threw aside the draperies of its couch and rose. Full 80 years had passed since last the star had shattered the symmetry of the northern crown. And where was I, its self-appointed guardian, on that once-in-a-lifetime night when it awoke? I was asleep. I'd set the alarm for 2:30 a.m, intending to get up to spend some time with the early morning variables. The alarm clock did its job. I looked out of the window and the stars were clear and bright, but apparently I was not. For I sneezed once or twice and got the feeling that I was coming down with a cold, or maybe even worse. Self-pity comes easy at 2:30 on a cold February morning. So I went back to my warm bed with a comforting thought that I owed it to my family and myself to take care of my health. And thus I missed the night of nights in the life of T. Coronae Borealis. It was the night that spectroscopists longed for. I alone am to blame for being remiss in my duties. Nevertheless, I still have the feeling that T should have shown me more consideration. We had been friends for many years. On thousands of nights, I'd watched over it as it slept, and then it arose in my hour of weakness as I nodded at my post. I'm still watching it, he wrote in 1980, but now it is with very wary eye. There's no warmth between us anymore. Very, very sad, but it's even sadder than that because he had actually observed something unusual about in the year before that T. Coronae Borealis was actually becoming fainter. And Harlow Shapley from Harvard sent out a telegram noting this unusual fading of the star. And we now know with hindsight, this fading, this pre-eruption dip, which I call the Peltier dip that Leslie Peltier identified, actually happened just before the eruption. So not only had they had the nous to think it might erupt again, but he'd also seen evidence that might be linked with a future eruption. He wasn't to know, of course. I want to talk about somebody else who also had great nous. So Celia Payne Gaboshkin was the first female to get a PhD from Harvard University. She was British. She was a member of the British Astronomical Association. And she actually met her future supervisor at Harvard, who was Harlow Shapley, at a BAA meeting in the 1920s. And she went on to be a great astrophysicist. And she wrote this book with her husband called Variable Stars, And I have to thank Alan Dowdall for giving me this book a few months ago. He's had it in his possession. It's an old copy from the BAA library, which when we closed it, he took possession of, and it's the book that was used as a review copy in 1938 for a review in the journal that was written by my predecessor as variable star section director. I was surprised when she was writing around about about Corona Borealis, T Corona Borealis. Bear in mind, in 1938, there were only 2 known recurrent novae known at that time. She writes, the star should be watched for variations, preferably by photographic methods. That it will prove to be a recurrent nova is not impossible. 1938, I mean, that's tremendous insight. She looked at the data and thought there's something suspicious about this star. So let's move on now to the 1946 eruption. There were 3 very early discoveries. The first was actually made on the evening in Universal Time, so 7 o'clock in the evening on February the 8th, by an amateur astronomer, a railway worker, Kamenchuk. He worked on the Siberian railways in the far east of what was then the Soviet Union. And he worked at this station, which was almost on the border with China. And again, it was the early morning for him when he went out onto the station. He saw this star. And amateur astronomer immediately knew that it was out of place and it was a nova. So again, he made a fatal error because he decided to write a letter. He wrote a letter to the doyen of variable stars, which is Professor Kukakin at Moscow University, which is some 8,000 kilometers away. And it took almost 3 months to get there. So the announcement didn't come out until May the 6th of that year. So it's now known, we now know about it, but it wasn't known at the time. Then surprisingly, there was this huge gap where nobody observed it. It wasn't detected until 2 observers in the United Kingdom found it. And I'm going to talk a little bit about that in a moment. So the first of these to detect it was Michael Woodman, more of that later. And the second one was Frank Knight. And probably the reason is, again, people tied up with other things in the post-war months. So let's first of all look at NFH Knight, or Frank Knight, as he was known to his friends. He was a BAA member. He joined in 1934. He began observing variable stars in earnest in 1936. Extremely active, lots of data submitted to the database. He was called away for military service at the outbreak of war in 1939. And there are some very nice excerpts of letters published in the journal in the 1940s that he wrote back home about some of his astronomical observations, which included observations of variable stars made in foxholes in the Western Desert during the campaign to push Rommel out of the desert. He also reported observations of the Gegenschein, observations of Venus. So he was still active as an amateur astronomer. He was demobilized in 1945 and resumed observing variable stars in earnest in December 1945, just before the eruption. He had a long break from observing. He went off to a career in banking and then returned in the 1970s. And here you can see him receiving the W.H. Stevenson Award of the BAA from the BAA president at the time in 1985, Heather Cooper. And it was he that discovered one of the independent discoverers of this nova in 1946. So thanks to John Toon, who's in the audience, I've had sight of Frank Knight's observing log. This is a variable star observing log for that day. He loved getting up early in the morning to observe variable stars. Early morning observations are really valuable because not many other people are out observing. So they have extra value, if you like. So he rose about 4:30 in the morning that morning. And he made his first observation at 4:48 in the morning, just before the beginning of astronomical twilight.
If you're wondering about the times he writes in the second column, this is Greenwich Mean Astronomical Time that was used extensively up until the 1940s. The reason being you don't have to change the date at midnight. So 1745 on February the 8th is actually 5:40 in the morning on February the 9th. It's just the nomenclature was used at the time. So he began to go down his observing list, knocking one star off after another. He observed the, I think it's a Mira star, isn't it? Corona Borealis. He made that observation, and he was just moving on to his favourite star, R Corona Borealis, when he suddenly saw this bright star that turns out to be T Corona with his naked eye as he was moving the telescope. So he phoned the Royal Observatory at 10 to 6 in the morning, the Royal Observatory at Greenwich, spoke to the night's watchman, reported his observation, and tried to convince the night watchman to wake the astronomers and go out and observe. And that was unsuccessful. He tried again at 9 o'clock, and that was also unsuccessful. What he'd been hoping is that perhaps the Greenwich would observe the star during the day. Their instruments were quite capable of doing that, except for the fact that they were still in decommission after the war. They'd been taken away and hadn't been fully put back in place. So at nautical twilight, 6:15, he made another observation at magnitude 3.4, early dawn, and then the sun obviously rose and it was daylight, and no further observations were possible. So. Again, thanks to John Toon, I've had some sight of the letters that are in the chart archives of the variable star section. And we have a number of letters written by Knight to W.M. Lindley, the director of the variable star section. They were actually really good friends. In fact, the previous week before the eruption, Lindley had visited Knight's house in near Epsom, so they're on good terms. You can also tell they're on good terms because he addresses the letter, "Dear Lindley," and he also has a little bit of humorous introduction. I beg to make known to you, Monsieur le Directeur, is how he refers to it. I think perhaps I ought to introduce that. And he goes on to say, at a particular time in the morning, just as I was about to observe our Corona Borealis, as is my custom, I was suddenly literally struck right in the eyes by the presence of a third magnitude nova in Corona Borealis. And he goes on to say that it was in the same position as the 1866 object, so he made that connection. Now, this letter revealed one other really important note, and it literally is a pencil note in the top left, which we know is in the handwriting of W.N. Lindley. This is a note that says 2026 to 2027 as the next possible eruption. He'd added roughly 80 years, and it mightn't come out quite as 2026, but that we now know is probably the first future prediction of what was now known to be the third eruption of this star. So Knight thought he had everything in the bag, but he was wrong, because when he opened the papers on February the 12th onwards, there were newspaper articles around the star being discovered by somebody else. And I love the headline: "Boy finds lost star. Newport boy found missing star. Boy makes star flare claim." And when you go into the details of these, some of these are better written than others. Daily Mail, not quite so good, but a few errors. But these were really important contemporary remarks about the discovery by this 15-year-old boy. So the question is, who is this 15-year-old boy? It's Michael Woodman. Now, Michael Woodman was a sixth form student at the time, studying in Newport. And this is a photograph from the local paper of him, and a 1946 photograph, I think, in his school uniform. Now, it transpires that Michael Woodman's father was a tax inspector, and he used to travel around the country on various projects. And for a while, he'd been working in Hull. And in the week leading up to this fateful weekend, Hull was his destination, and he wanted to get home to the Newport family home in time for the weekend. And he got the train to London, but then he missed the connection to Newport. He phoned home, and it reported he was going to not be back to the early hours in the morning. And the young 15-year-old Michael Woodman thought this was a great opportunity to pursue his astronomical interest. He'd been interested in astronomy for about 3 years, and stay up late to observe the stars. And that's exactly what he decided to do. And this is a Google map of Newport. You can see, just orientation, there's Newport Station. By the way, I went through Newport Station on Monday, and it didn't occur to me before then that actually the address where Michael lived at is actually quite elevated. And that's his house. And not only that, he was observing from his bedroom window, which was at the back of the house on the first floor. And he was looking in this direction. It's from 61 Queens Hill Crescent. It's now called 73, so been renumbered. Across the school playing fields, which I now notice have been dug up. I don't know whether you knew that, but there's another housing estate, but almost due east. And this would have been the view that he would have had from his bedroom window at the time of 1:45 in the morning of February the 9th, 1946. Corona Borealis would have been about 28 degrees in altitude. It's marked here as the blaze star. That's one of its unofficial monikers, but you can see where it is. So 28 degrees above, just north of east horizon. So in the prime direction where Michael Woodman's window was facing. And he discovered it, and he was excited. His father came home. He described the events to his father. And the father was obviously very proud, as were the school teachers, and hence there was a lot of interest and excitement, and hence the newspaper reports. But what Michael wanted to do was to write to the Astronomer Royal at Greenwich with his observation, and Michael has kindly shared with me the reply that he got from Sir Harold Spencer Jones to that letter. It was written on the 12th of February, so he must have written by return. And he says, "Dear Master Woodman, thank you for your letter. I should like to congratulate you for noticing that there was something unusual in the constellation of Coronae Borealis, and for reporting it to me. You have, in fact, made a very interesting observation." And it turns out that at that time, the star was almost at its peak. It was just below its peak. Michael says it was just slightly brighter than the other stars in the Northern Crown, and probably about the same brightness as as Polaris. So we know roughly it's say magnitude 2, which was brighter than when Knight saw it a few hours later. Because of the excitement, the BBC got involved. More of the BBC later, but this is a letter from the BBC inviting Michael to the studios to take part in a broadcast that took place, I think, in April of 1946. Broadcast from or recorded in the Cardiff studios of the BBC, and there was another invitation later in the year, I think in November, to the BBC in London for another broadcast. So, looking through the letters between Knight, the other independent discoverer, and Lindley, it was clear that Knight felt, well, just maybe slightly miffed that he was pipped at the post by an enthusiastic young man from Newport, but he soon got over it, and I was delighted to see it. Well, in the earlier correspondence to Lindley, Knight said, "Can you send me Michael Woodman's address, or can you find out so I can write to him myself and congratulate him?" And I thought, I wonder whether he ever did that. Well, he did, because this is the letter that Michael Woodman received. And it's written on the 7th of March, so a month after the eruption was detected. "Dear Mr. Woodman, the director of the variable star section of the BAA has suggested that I should write you this letter, since you and I were joint and independent discoverers of the recurrence of T Coronae Borealis a month ago. I'm pleased to be able to tell you that at the meeting of the BAA last week, the honour and credit for the discovery was shared equally between us, your own priority being fully recognised. So that was a nice letter to receive, but it also contained a light curve that Frank Knight had plotted for the first month's observations of the Nova eruption. The dotted line, the solid line, are the BAA variable star section observations that were known about at the time. And you can see the observation here, which is the discovery here is the discovery by night. Well, I've since plotted, I put a dot on that plot corresponding to Michael Woodman's observation, which is the red cross. And in fact, you can see that's bang on the light curve of the 1866 eruption. So that's an important observation in its own right. Now, I was intrigued as to actually who Michael Woodman was, and was there any possibility to meet him? And to cut a long piece of research that was largely conducted by some very good colleagues of mine, we managed to track Michael down. Last August, I wrote a letter to his son, John, and then a few days later, I had the pleasure of having a telephone call with Michael and visiting him at his home in East Grinstead. And I can assure you, he remembers that night like it was yesterday. And he provided so many important details that were unknown from the press cuttings and official reports, like the precise times and the brightness, that I thought this was so valuable that I wrote this up as a short note so that people in the broader sphere could recognise this very early independent discovery. Now, for those of you that were listening to BBC World Service at 2:30 in the morning on December the 30th, is the first I've heard, or various news bulletins during the day on the radio and the TV, but certainly on the BBC 10 o'clock news, you will have seen Michael Woodman being interviewed and heard him being interviewed about that night. It was a wonderful piece of reporting. It was factually correct, and it talked a little bit about the next eruption. So I thought, as did my colleagues that in the variable star section, so my colleagues, section officers, that this independent discovery by Michael Woodman was so important that even though it's how many years later, 79 years afterwards, we really should recognise this amazing contribution that he made. And for that reason, we have decided to award in the variable star section's Charles Butterworth Award. This is the most prestigious award of the variable star section. Charles Butterworth was a very active variable star observer in the first half of the 20th century. He was the first person anywhere in the world to amass 100,000 observations of variable stars. And hence it's fitting that the award is named after him. But more than that, it's more than fitting that the recipient of this award should be Michael Woodman. And I have the award here. And Michael is here, if you hadn't realised. It's a great pleasure to be able to invite him, his son John, and part of the extended family as well. So, Michael, here is a certificate with your name on.
Forgive my not getting up.
No, please. We're just going to take a few photographs. So, you did us proud. Just there's cameras over here. So if you look, there's the official one over there. Take some just of Michael on his own. Thank you. So, you said you were honoured, but no, we are honoured. Yeah. You have done us the honour of coming today and being present with us today. It's such an important discovery that you made. And I'm just so glad that people now know about it. And yes, please enjoy the award.
Quite overwhelmed, really. I'm really glad that I did in fact keep all the paperwork 80 years ago.
Yes.
And it's still there, available to the society if you want any further information from local press. I've got several cuttings there.
Thank you very much.
We're delighted, and my family are very supportive on this, and a number of them, one who actually isn't here, my second son, I have three.
Yes.
He's away on holiday. Three altogether.
Yeah.
But he also is interested in astronomy and has done work with telescopes. So it's in the family.
It's in the family.
Been able to pass it on a bit.
Thank you ever so much, and well done for your contribution.
Good, thank you.
The rest of the talk, if you wouldn't mind putting the lights down, I'll continue with the talk because this gentleman has done his work. He's detected that eruption in 1946, and now it's down to us to find the next eruption. And who knows when that's going to happen? I certainly don't. But what I dearly hope is that as soon as we hear about it, we'll get a message to Michael. And I know the family is keen to get you out to a dark sky somewhere on the outskirts of East Grinstead to be able to see that for the second time in your life, because I'm not sure if there is anybody else. I doubt if there will be anybody else that has seen two eruptions of this star.
They're all pending instructions as to where to drive.
Well, we'll assist with that. So let's have a look at what T-Core Bohr has been doing in the recent past. So this is a light curve that goes back, I think, to 2008 till the present day. For about 69 years, it wasn't doing very much apart from these up and down. You remember these orbital modulations I talked about? But suddenly in 2015 February, it brightened by about 3/4 of a magnitude, and it remained that time until the spring of 2023. And we now know that is called a super active state, and it seems to be where there's a lot more accretion within this binary star system. Now, the curious thing was that Brad Schaefer in the United States has taken that light curve, which is the blue dots here, and superimposed on it with the purple line, which is the eruption of 1946. And that superactive state started around about around 10 years before the 1946 eruption, just before the dip, this Peltier dip that I've described before. So similar things seem to be happening 2015 to 2030. And we began to think, whoa, this is fading quite quickly now. Is this the dip before the eruption? The general trend is down. The ups and downs are again this orbital modulation, so you have to kind of filter those out. But now it doesn't seem to be playing the game because it's been brightening. In the last few weeks, people have been reporting also spectroscopic observations that show that the accretion level is going up. Now, that is not a bad thing if you remember that for this thermonuclear reaction to occur, you have to, the white dwarf needs to accrete a certain amount of critical mass of matter. So the fact there's more accretion means that there is more accumulating on the white dwarf. So that's good, but who knows that it's going into eruption. Lots of people have had bets and stabs at this. So I constantly get asked when the next eruption is. So folklore, in other words, what I've read in Patrick Moore books when I was a small lad, is that it would be around 2026. So that's just adding the 80-year difference between 1866 and 1946 to the 1946 eruption. Lindley, as we saw, said 26 to 27. I'm not quite sure where he got his maths from on that, but that's what he said. Brad Schaefer has looked for previous eruptions. So we know the 1946, we know the 1866, and he's found another one in a catalogue by Francis Wollaston in 1787, which seems quite a certain one, which was 78.5 years before 1866. And he's looked back through all kinds of records to find a potential other sighting in 1217. And he calculated that that's roughly 7 times 81 years. So you can already see that it's not exactly consistent each time. It's recently it's been less than 80 years. If you were to add the last delta to 1946 February, you come to 25 October. So is it going to be later this year? Schaefer himself did another, when he saw this, noticed this superactive state beginning, he did some analysis on the data, and that's when he came up with a date between March 2024 and September 26. He refined that in 2023 when this pre-eruption dip began to end, and he began to say, well, actually, it's pretty imminent. And that's when he came up with 2024 February to September. I don't need to tell you that we're past that. And I actually met Brad at the AAVSO meeting in Huntsville, Alabama in November. So I was pulling his leg about this. And he said, it's still only a fraction of a standard deviation before his prediction. Well, it moves on a bit. So we're already, pretty much just over a standard deviation beyond. So other recurrent novae are not precise in terms of their eruption interval. So it may be a false hope thinking that these numbers are so consistent. There was a report in the middle of last year, a paper by Schneider, and he worked out the number of orbital cycles, so the number of 227 days between these two eruptions. And he came out, well, the next time that happens is going to be 2025, March the 27th. And 227 days later, it's going to be November the 10th of this year or later. I struggle to think that there is an astrophysical connection between the orbital period and when it goes off, but who knows? That's why it's so important to keep observing this star and to understand more about it. So how do you observe it? Remember, people are looking at this every 6 minutes on average, but of course the average may mean that people have been clouded out over Eastern Europe and Russia. So maybe it's clear in this country, and after a few hours we get clear skies and see the star. So if you were to get up tomorrow morning before dawn, this is 6:30, the sky is 6:30 tomorrow morning. You can see, if you're looking southeast, you can see, move over here, the summer triangle just coming up, so Deneb in Cygnus, Vega in Lyra, and Altair in Aquila, very low in the sky. Very high in the sky is going to be Ursa Major. You can just see his tail near the zenith. If you follow the curve of the tail round, you get to Arcturus in Boötes. Boötes on his side, rising, and just below Boötes, tucked in, is Corona Borealis, the northern crown. And just below that is where the star would appear. So it's just, this is a magnified view of the northern crown. You can see T is just outside. So, and there are variable star section charts that you can use should you see this star to make visual estimates. So that goes to the next question. Well, how do I observe it? Well, first thing I want to point out is that as soon as you hear this eruption announced, you've got to get out there because it doesn't last very long. It fades around 3 magnitudes in 5 days, and within a week it's down to below naked eye visibility. So you've got to have clear weather over those few days. It so happens that here we've plotted, or Brad Schaefer has plotted, the last 2 eruptions, 1866 and 1946, and they're virtually superimposable. The eruptions were identical. Very fast fade, and then it was in quiescence for around 80 days, and then there was a second smaller eruption called a secondary eruption. I think this is the only nova that is known to have a secondary eruption. The astrophysicists still debate what's causing that, and we hope to find out next time round. The current theory is that after the first eruption, the system is still really hot after that thermonuclear explosion. It's still accreting material from the red giant, so it doesn't take too much effort for there being sufficient material accumulated a second time for a smaller, and it's probably around 8 to 10 times smaller eruption. It doesn't reach naked eye visibility. It's about 8th magnitude, but it does last for longer. It lasts for about 90 days.
Do we have any idea what the rise time is?
It's hours. So in 1866, it was observed about 3 hours before our John Birmingham by a guy in Athens, Julius Schmidt. So no, we don't. But other novae, it's hours. It really is a very, very fast reaction. So visual observing is key. Can be key here. You only need binoculars to look at the Northern Crown and see if it's there. A small telescope, you should be able to see T Coronae Borealis itself. It's around 10th magnitude. Of course, it's be obvious when it goes into eruption, and you should observe it every night or even twice a night. Digital observers, so with CCE cameras or CMOS cameras, they're also observed with those. I know a lot of people are now beginning to use these automated smart telescopes, and even people are doing daytime observations. So at the moment, it's a difficult to access field, and the sky can be lightening at the time. So it may be that the big surveys are avoiding that time. So this could be a time for another amateur to discover it. This is Arnie Hendon's observatory in the United States. That's his telescope. There's a remote telescope there, and he's got a cake tin on top with a little cutout for observing the star during the day. And he's getting some fairly decent photometry in broad daylight. And of course, spectroscopy. The spectroscopists have been doing an absolutely brilliant job over the last few years following this, as they will as the eruption takes place. So drawing things to a conclusion now. So here is the light curve from the variable star section database. And on it, so you can see Knight's discovery, but on it I plotted Michael Woodman's discovery just at the top, and Kamenchuk's discovery that was announced some months later. So that's the shape of the light curve. Now, I think what I hope I've been able to show you is that both the last two eruptions were discovered by amateur astronomers, and that they discovered it because they knew the sky well. They knew something was out of place. Michael knew immediately there was something out of place when he saw it. That's odd. That's odd was the words he used to me. So fortune favours the well prepared, as Louis Pasteur says. So yes, an amateur astronomer that knows the sky well is well prepared, but also one that looks at the field when perhaps others aren't looking at it. And that includes January and February and into March of a year when the field is low down in the sky. When Michael, of course, just discovered it in February. Rapid communication, so put it on the BA forum, whatever. There are various internet groups that you can post to. Don't write a letter now. So yeah, post it somewhere. Because every moment, every discovery, hour, day after eruption is so important to get all those telescopes around the world looking for it. So every minute really does count. And what I hope I've been able to show you is that Michael Woodman's observations, the details of those have been instrumental in constraining that first part of the light curve of the eruption, where there were so few observations made. Really important discovery. Couple of acknowledgements. Well, obviously the first one is to Michael himself. So thank you, Michael, for sharing your information. Michael earlier mentioned his archive of newspaper cuttings and letters. I thoroughly enjoyed going through that, and really fascinating contemporaneous material that has been extremely helpful. And I'd like to thank his sons as well. So John's here today, Nick and Richard and the extended family. I'd like to give a shout out to two colleagues that helped me track down John through their ancestral research. So Finbar Connolly in Ireland and Andrew Holmes in Cheshire. They worked together on a number of different projects, it seems. Thank you for people that provided some of the historical perspectives and insights and documentary evidence. So John Toon and Bill Barton and Richard McKim. Lots of discussions with a couple of professionals that were also encouraging me to get Michael's observations better known. So Professor Brad Schaefer in the United States is probably the most knowledgeable observer of theoretician around T Coronae Borealis. He is a Nobel laureate, I should add. He was on the Nobel Prize with Perlmutter on the expansion of the universe, and Professor Nye Evans. So with that, please observe the sky. I've no idea when it's going to go off. It doesn't take much effort just to look, except perhaps getting out early in the morning, or staying up late as Michael did, but certainly not staying in bed like Leslie Paltier did.
Wow. And what a list of famous names up there, contributors to your archive and so on. And what a pleasure, Michael, that you could come along today. Absolutely wonderful that we
Yeah,
could
just
see you.
a note of thanks to Professor for such a brilliant exposition of the whole series of things that have happened in connection with this star, which I didn't know about, and it's been really very well worth hearing. Thank you so much.
Thank you very much. That means a great deal to me. Thank you.
So, have we any questions from the floor? Not that I can see anybody.
Yeah, I can see a question hand going up.
Oh, Adam, yeah.
Just looking up on Wikipedia, the white dwarf is surprisingly close to the Chandrasekhar limit. Would the T. Coronae, Borealis, or other similar stars be progenitors to a type 1A?
So the general class of interacting binary stars, so it's a white dwarf with another star going around, it could be a red dwarf or a red giant, are potentially progenitors of type 1A supernovae. When they keep accumulating mass on the white dwarf, and when it reaches a Chandrasekhar limit, then bang, they go. Now, whether this one will or not, we don't know. There are still some fundamental questions about what type of nova it is. Some people have speculated it's a neon type nova. And again, that's the sort of information that we will find out when it next goes bang. So nobody knows whether it will erupt as a supernova.
It would have quite a bright apparent magnitude if it did.
So it's quite close. That's
Yeah.
one thing I hadn't mentioned. So one of the instruments that is lined up to look at this, you can't actually point it, are the neutrino detectors. So things like Super Kamiokande. So these are big baths of water deep in the earth to look for neutrinos, because it's possible that some neutrinos make it this far.
Even for just a normal nova.
Even for nova, it's sort of 50-50, the calculations. Some people say yes and some say no. We'll be looking out for it.
Paul, you have a question?
Yes, Jeremy, fascinating talk. You showed a slide with the observations, but it looked like a printed form, but you said it was from a notebook. I just wondering if that was able to get, or whether it was a presentation form.
John, you know about that. John's just behind you. The sheet that that Knight used to record his observations, was that a standard sheet in use at the time? Do you know? Yeah. Okay. It's a form rather than a book. I understand. Yeah. I think Paul just wants one because it has Greenwich Mean Astronomical. It used to be arcane in his time. Anything's possible.
Okay, well, thank you very much again. A sigh of relief. I thought you'd disappear, Mike. We move on now to the last talk of the evening. Mike Foulkes, who is our director of the Saturn, Uranus and Neptune section, has very kindly agreed to deliver the sky notes. Now, earlier today we had council meeting, as we enjoy, I think is the word, before the afternoon meetings, we're always interested in anyone who would like to volunteer to do the sky notes. It does seem to fall a lot to some of the same people. So it's not obligatory that you have to be on council or anything else. So anyone, there's a few very regular faces here that I just think maybe would be keen to do sky notes someday. And we'd see a few different people. Let you and Nick and others off the hook for a while. Any hands going up? No? I shall have to work on them in the bar. That's what normally works. Anyhow, are we ready to go, girl?
I think it used to be easier when we had slide projectors. Anything that could go wrong. We're ready to go. Get up in there. Take it like it up. Right, I will do. Yeah, yes, yeah. Just give me a 5-minute warning. Yeah, throw me out at 5. Yes, please. I think I can see where the keys are. Yeah, great stuff. Well, good afternoon, everyone. Welcome to these Sky Notes rather than Skynet. A belated Happy New Year to everyone. And it's a few days in. And usually at New Year, people are sort of have New Year resolutions. Often is it not, it's to get rid of this, the Christmas excess. But I'm sure as amateur astronomers, maybe it's saving up for a brand new telescope. Oh, it's not going. That's ruined my joke.
If you flick the mouse into it, it will.
This one, okay, right, that's it. I'm sure even Premiership footballers couldn't afford something this big, but it's an aspiration. But as we go into the new year, there's always some interesting things in astronomy. This year is no exception. The only downside would be if it was clear, and the weather's been really rubbish lately. Also, a lot of the images I'm going to show today, it was a very difficult choice given what was available on the BAA website, and very much a sort of random choice really. But we'll begin with the sun, and the sun has been active again. This is a nice image by Nick using a 90mm refractor. See lots of sunspots, and this seems to be another image by Honor Wheeler. Again, not a big telescope. You can get nice views of the sun with small refractors. And if you're lucky enough to have something that looks in hydrogen alpha light, like this image by David Strange, using a 90mm solar scope, you see all the prominences on the side, all the filaments, which are prominences effectively in projection onto the sun. And because of the sun's ongoing activity, we have had a few aurora. Certainly last year was a major year for aurora. We had some great displays that got even far south of the country. One in May, one in October, really good. And there was one or two over New Year. And this is a nice image by Steve Brown in North Yorkshire. Got Venus on the bottom, part of an aurora, and even a meteor, which is pretty good. I don't think it was a quadrantid. Another aurora is on the 1st of January, seen from Scotland. Scotland obviously see auroras better than we do down here. This one by Ian Cartwright, which shows the aurora quite nicely. Another person who takes excellent auroral pictures is Jimmy Fraser. And this one was on the 4th, and you can see this nice colour banding of aurora. Now, moving on to the moon. These are the phases of the moon from now until towards the next meeting. And you'll notice the full moon on March the 14th I put in red because on this particular full moon, we're going to have an eclipse of the moon. And eclipses of the moon, I think, are rather nice. They're not as spectacular as solar eclipses, but I still think they're nice events to observe. And I think even an eclipse of the moon would inspire an 11-year-old to get interested in astronomy. There is sort of bad news and sort of bad news with this one. First of all, it's an early morning eclipse, so it means getting up, like for T Coronae Borealis, getting up in early. And the really difficult thing is that it'll be, by the time it reaches mid-eclipse, it'll be setting for this country. It varies a little bit from your longitude, but it'll be setting. So to observe this, you'll need a good southwestern horizon. We'll certainly be able to see the penumbra, which is faint, then the first contact with the umbra just after 5 o'clock. And the moon will be setting then, but it's well worth getting up to go and see this. The moon is a great object to observe. You can see things with the naked eye, you can see things with binoculars, and of course with a small telescope. And a lot of people decry the full moon, but I think it's still an interesting thing to look at. See a lot of the ray craters, obviously Tycho here, and Copernicus, and this nice image was taken by Anton Matthews using one of these sea stars. And I know some people decry sea stars, but I think they're actually quite good little things to use. You can use them on all sorts of things. The only thing they're not really good at is the planets. We can see lots of ray craters. Up here on the Mare Crisium, here is the bright crater Proclus. You see the rays from Tycho more in this direction, which probably indicates that the impactor came in from that direction, and also variations in the tones of the mare. Talked about Proclus, which is on the Mare Crisium, and this nice image by Carl Frederick Hansen shows the Mare Crisium and again the bright crater Proclus here. So even with small telescopes you can see quite a bit on the moon, particularly if you're looking towards the Terminator. A nice picture by Alan Halsey of the Apennine Mountains, stretching from Eratosthenes at the bottom. We've got the crater Archimedes, Paracelsus and Autolycus up there. And I've looked at this image in quite detail, and you can even see the Hadley Rill, close where the Apollo 15 astronauts landed. And a very nice view of this mountain chain, which can easily again be seen with small telescopes. Another nice one, this image by James Dawson, is the floor-fractured crater Gassendi. I've got a personal interest in this crater because it was one of the first ones I identified as a young kid using a small telescope. And it's a very nice, Gassendi is full of rills, cracks in its surface, and also we've got mountain stuff around it. And also the moon does occultations, and on January the 4th there was an occultation of the planet Saturn, the second one over the last few months. Where I was, it was cloudy, unfortunately. We've got two nice images of this occultation. The first by Alan Tuff, where you see Saturn almost going behind the unilluminated disk of the moon. And this one by Matteo Piccoli in Italy, showing that Saturn just after it's emerged. There is, in fact, another occultation, not of Mars, not of Saturn, but of Mars appearing in a few days' time, in February the 9th. Unfortunately, it won't be visible from this south part of England. But actually, if you lie to the north of this line, up in North Scotland, you'll be able to see an actual occultation. And if you actually lie on this line, you'll see a graze. So from where we are in England and southern Scotland, we'll see Mars very close to the southern limb of the moon. But if you actually live a bit further north, you'll actually see an occultation. So I hope somebody will be able to see it. The last few months have been really good for planetary observers. All the bright planets have been visible, and certainly Mercury is probably the most elusive. It's at conjunction in a few weeks' time in February, but there'll be an eastern elongation on March the 8th. The angle of the ecliptic at that particular time will be rather shallow, so it's not a favourable one, but it's an elongation of about 18 degrees. And if you've never seen Mercury on the 18th, Mercury will lie just to the south of the planet Venus, which will make a really good guide for it. So if you've got a pair of binoculars, you'll be able to pick up Mercury as well. Some people have been observing Mercury, and I'd like to just show, this image by James Dawson. One of the experts in imaging sodium trails has been Chris Hooker, and James has been in contact with Chris Hooker for some advice, and he's managed to image this tail from Mercury. He did this in December, which is a remarkable observation. I don't know how it shows at the back, but if you can't see it, there's a trail going on there. Chris advised James on the filters to use. He only used a 120mm refractor. So that's a really good observation. Anybody who's gone out, and if it's been clear just after sunset, will obviously pick up Venus. It's bright, it's moving northwards up the ecliptic. It reached its greatest elongation in January the 10th, and it's now moving back towards the sun. and we in Inferi conjunction on March the 23rd. Tonight, if it had been clear, this would have been the view just after sunset, and Saturn and Venus would have been fairly close together. And there's been a few observations of Venus, a couple of nice ones, one by David Basie using a large Schmidt-Cassegrain telescope in ultraviolet. And this, it probably doesn't show it too well, but this is a visual observation using 102 millimeter refractor, and that's almost at dichotomy when it's at half phase. And that's the bright part and then the dark part of Venus there, which you can't see unless you do something special. And these are two images by two very good planetary imagers, Martin Lewis and Peter Tickner. And they've been trying to image the night side of Venus. And of course, it's dark, you won't be able to see it. But pick it up by using its thermal radiation, by using specialist filters, about 1,000 nanometers or a little bit higher. And they've both managed to capture images that show part of the dark side of Venus. This particular one of Martin's, you can see the continuation of the planet. And I'm sure these two observers will be making further observations of this dark side, particularly when Venus goes into a crescent phase. If we observe a little bit later on in the evening, if it's clear, there are two planets that dominate the sky. Venus will be set in the southwest, but we've got Jupiter and Mars. Jupiter is near the Hyades, and Mars is just south of Castor and Pollux in Gemini. Both easy to spot. Mars was at opposition a few days ago on January the 16th. The only downside of looking at Mars is this particular opposition, the angular size of Mars is rather small. It's just under 15 arc seconds across. It makes it a little bit more difficult to see detail with small telescopes. However, Jupiter is very bright, and a small telescope will show lots of detail. And many people have been observing Mars, and this the Mars observations are shown a bit south at the top, unlike the other planetary images I'm going to show. And there has been some evidence of dust storms even on the sort of North Polar Cap. And this is a montage produced by the Mars section director, Richard McKim, and shows some of the dust storms entering into the North Polar Cap. And here we see Mars's most famous mark in the Syrtis Major. Other observers have been making quite nice observations. This is a nice one by Tom Williams in Wiltshire. Admittedly, he's got a 24-inch telescope, rather envious. But what we can see here are bright spots with clouds very close to the Tharsis Plateau volcanoes. And that's a rather high resolution observation. Can you say about this one by Martin Lewis? Again, rather envious, 400mm telescope, which shows some of the major features like the North Polar Cap. Syrtis Major is over on the left. Sinus Meridiani is in the centre, Mare Achidalium is on this side. And this shows some of the detail that can actually be resolved. I wonder how long it is before amateurs started producing images that show Martian craters. I don't know. Come on. And this nice image as well with a 10-inch 254mm Schmidt-Cass, again shows the Syrtis Major and the bright North Polar Cap. So this is the sort of things you can look out for even with a small telescope. And of course, visually, you'll be able to see quite a few things as well. And this nice observation by Paul Abel, using his 300mm Newtonian, shows the rotation of the planet. You observe from nearly 9 o'clock one night until after 11, and you can see how the Syrtis Major has rotated around the disk. Jupiter, however, has been very prominent, and the red spot, as everybody knows, has been shrinking over the last 15 years, and is not particularly prominent now. And this nice image from Luigi Moroni in Italy shows the red spot, the activity to the side, and there's also loads of other features that are visible as well. One of the nice things about observing Jupiter is that you can, oh sorry, I'm telling myself, and this is another observation, the other side of the planet. You just see the red spot going off the disk there by Bill Leatherbarrow from Sheffield. Bill is always complaining that you never get any good seeing in Sheffield. But you can see actually, this is pretty good actually. You can see lots of detail on the planet. There's activity on the edge of the South Equatorial Belt, there's activity in the equatorial regions, and it's all good stuff. Now, one of the nice things I find about Jupiter is its 4 satellites. Even a small telescope or a pair of binoculars will show the satellite. And even more fascinating, I think, is when they go in front of the planet in transit. And this is observation made by amateurs using larger amateur telescopes that show the shadow transits close to opposition. And as you can see, the shadows and the satellites themselves are in fairly close angular separation. Also, what I think is nice is that these high resolution images are actually showing details on both IO at the top. If you look here, it'd be difficult from the back. You can actually see the darker polar caps of Io, and you can also see markings on Ganymede. So some advanced amateurs are actually imaging features on the large Jovian satellites. But to prove that you don't necessarily have to have a massive telescope to do this thing, this is a nice observation by a Portuguese amateur, Miguel Aurelio, if I pronounced his surname correctly. And it shows the Great Red Spot, and it shows Io and its satellite. That's Io there, that's its shadow. And the inset here is a blow up of that. And this too shows the darker polar caps. It actually resolves the disk very well. So even with a sort of 200mm telescope, you can, with good seeing, make observations about this. But interesting things have been happening on Jupiter. And certainly on January the 10th, there's been a major outbreak starting on its north temperate belt. This is one of the early observations by Clyde Foster in Africa. And this bright spot here is the start of the outbreak. We get outbreaks in the jet stream that's in the north temperate belt. Other observers were able to pick this up. Here's a nice image, again by Clyde, using methane band. And if the object's high in Jupiter's atmosphere, it'll appear very bright. And you can see this outbreak is very bright indeed. But just to give you some idea, it also can be visible from the UK if we get the right seeing. This is taken by Manokardisis in Greece, and a methane image again shows the spot bright. Images from the UK. This is by Jeff Lewis in Norfolk, and the outbreak is just sort of there, just going off the limb. So even with the rubbish seeing we get in the UK, it can be observed. And again, another breathtaking image by Martin Lewis, not only showing the spot at the outbreak, but activity and outbreaks in the south equatorial belt, and one of these dark barges in the north equatorial belt as well. And an observation from Japan, Miyazaki, again showing this outbreak here. What is interesting, however, our section director, John Rogers, you in the audience, John? I can't see. It's very good. Yes, you're there. Yes, you actually predicted fairly well when this was going to take place. Do you like to elaborate on that, please?
Yeah, these typically go off every 4 to 5 years. And there's been a run of them since 2007. And the period used to be 5 years. And you never know if one you see is going to be the last. But we strongly expected there would be another one because the north temperate belt has become invisible. And also we had measurements of the speed of the north temperate jet from amateur astronomers last year, showing this has risen to a one told me that there's going to be another outbreak. And indeed, it's taken 4.4 years after the last one. But I could say, I mean, maybe Mike's going to show more pictures of it. These were all on the first 24 hours of it. It is now that single bright spot, beautifully elaborate. And there might be more to come following it later.
So get your telescopes out and look at Jupiter and see this nice belt. Unfortunately, I haven't got time for other Jupiter pictures because I like to move on to another object, Saturn. I showed this diagram a few months ago at another Skynet, and it shows the ring inclination. If you've been looking at Saturn over the last few months, you'll notice that the rings are rather narrow. And this plot shows, the blue line shows the ring inclination to the sun. If it's positive, we're looking at the north face of the rings. If it's negative, we're looking at the south face of the rings. The wavy line is the view that we see from Earth, making allowance for as the Earth goes above and below the plane of Saturn's orbit. And as you got to quite big in December, it's now rapidly dropping off. And the rings will be edge on to the sun as seen from the Earth, towards the end of March, which unfortunately is only a few weeks after solar conjunction. And then there'll be edge on to the sun again in May. And there is a gap. That gap is potentially the unilluminated face of Saturn's rings will be presented towards us. Unfortunately, sometimes this can actually be detected from the Earth by where the sunlight reflects off Saturn in a manner to Earthshine. But because we're so close to solar conjunction, I think it's a forlorn hope. But if you want to see really narrow rings, next year towards the Christmas time, the rings will be very narrow indeed. But because the sunlight is getting less on the rings, they have actually been appearing a little bit less bright. Come on, that's better. And this is a nice image again by Jeff Lewis, taken just before New Year. And you can see the rings appear less bright than they normally do. Admittedly, you take an exposure for Saturn and the rings will appear very bright. Then fix it for Saturn, they obviously must be fainter because they appear fainter in these images. Saturn is always a difficult object to see spots on like we do on Jupiter. But this is an image by Trevor Barry, who uses a 400mm Newtonian. And apologies to Trevor, I've actually done a bit of enhancing on this myself to try and highlight a couple of features. We've got two of the satellites, Rhea and Enceladus, shown up. With the top arrow, there's a fairly fuzzy spot. And this is this long-lived vortex, the anticyclonic vortex that has existed in Saturn's atmosphere since 2010. And every year we think, is this going to last? Is it going to disappear? It looked faint in images taken by Hubble in August last year. And it's sort of starting acting like the Black Knight out of Monty Python. You chop its arms and legs off and it still keeps going. And this thing still keeps going, even though it's getting smaller and smaller. Another thing that's interesting is there's been a series of white ovals seen in the planet's southern hemisphere. We know they're real rather than noise because they move with the rotation of the planet. I'm hoping these persist, and as the planet gets better placed for northern hemisphere observers, maybe some people will be able to pick these things up as well. But if you're interested in Saturn, there was some sad news in November last year because sadly one of the BAA greats passed away, Alan Heath, or I should say more particularly Dr. Alan Heath, who had an honorary degree bestowed upon him from Nottingham Trent University. Alan was an avid observer of virtually everything, the sun, the planets. He was a predecessor, he was director of the Saturn section for 2 sessions, I believe. And he also, I didn't realise, was a keen amateur meteorologist and natural historian, particularly from life in ponds. I think a lot of people said, where did he find the time to do all these things? He was really involved in a lot of things. But in one of his last letters to me personally, maybe to other people, well, he said he was looking forward to see some of the shadow transits of Titan that were taking place nowish. Sadly, he never got his wish, but his funeral was a few days ago on January the 7th, and fittingly that night there was a shadow transit of Titan, which from my place the scene was fairly awful, but I managed to see it. But these are two nice images taken virtually concurrently by Jeff Lewis and Peter Tickner, showing Titan's just off the screen there and its shadow going across the disk. In fact, I believe Richard McKim actually managed to observe this with a small 70-80mm refractor. So not a difficult object to spot if you've got the right seeing. Uranus is not too far from Jupiter. I was talking to a gentleman earlier, his name, he said he's actually seen Uranus with the naked eye, which is possible if you get to dark skies, but binoculars will show it. This is a nice image showing Uranus overexposed, but the 5 major satellites, Titania, Oberon, Ariel, Umbriel and Miranda. And high resolution amateur images of Uranus have shown a very bright polar cap, which is quite good. Now, there's something to keep Nick happy. A comet 2024 G3. This is an image of it taken by Nick remotely from Chile. It seems to have got past perihelion, it's been bright. I think it got up to -4, something like that. The downside of it is it's coming to the evening sky. It's moving away from the sun fairly rapidly, so the elongation from the sun is increases. It's getting up to about 18, 20 degrees sort of nowish, but it's also moving south. It's also fading. And I must admit, as of yesterday, I'd only seen a few images of this. Here's another image of the comet taken remotely by Michael Buckner, been using one of the remote observatories in Spain. Nick, have we got any further news on this comet?
So yeah, it's a sun-skirted comet, so it got very close to the sun, 0.09 AU at perihelion. It was relatively small, so we didn't know whether it was going to survive. It has done, and actually its brightness is holding up quite well. So the latest estimates are that it's still about 0 magnitude. But it is at a very small elongation still at the moment, and as it's moving further away from the sun, it's moving south, and so it's really a southern hemisphere evening object.
Yeah. Have we got any chance over the next few days if the
Not
weather
from
clears?
here, no. I think it's pretty much had it now.
It's had it.
Here, but from sort of a bit further south, so southern Spain, Canaries, maybe there's a possibility of getting it over the next few nights.
Yeah.
And then the tail might be visible to us actually. There's a possibility if the tail maintains its structure and length that we might be able to image the tail from here in a darker sky.
Okay.
Yeah.
Right. Well, related to some extent, this computer doesn't like my tapping, are meteors. And as just an aside, again, come back, John was telling me just before we go and get onto the quadrantids that he'd seen something on the BBC News where somebody said they'd imaged a meteor falling onto their garden. Is that correct, John, what you told me? Yeah, I hadn't seen that. I've been busy. Anyway, the big meteor shower recently has been the quadrantids. They have a lot of activity, but the peak is very narrow. And unfortunately for us, it occurred in daylight hours on January the 4th. It's also cloudy from large parts of the country. I don't know if anybody had any chance of looking for the quadrantids. But this is a nice image of one quadrantid taken by Callum Potter. Apparently this got to about -3, -4, so that would have been quite spectacular. There's this rather nice image taken by Paul Whitemarsh from Upfield, wide angle lens, and I don't know if you can see at least 1, 2, 3, 4, 5 meters of radiating away as part of the quadrantids. That's a really nice image indeed, and it gets the idea of a meteor stream coming towards you. We've got an excellent presentation on T. Coronae Borealis by Jeremy today. I think again it's a privilege to have one of the co-discoverers in the audience. And as Jeremy has indicated, that nobody really knows when it next is going to appear. I don't know about any other people, but where I am, the theatres that around me often have acts that are tribute bands to bands like Queen, Elton John and so on, a few comedians, and very occasionally you get a sidekick. Not that I'm into this at all, I think it's a load of rubbish. The only thing I can guarantee about these psychics, they will know that I will not be booking tickets. But in sheer desperation, just to see if we can get an idea, if we're looking at a crystal ball, I don't know if this, but nobody knows when this is going to appear. So we'll just have to hope, but keep looking. But interestingly, Jeremy said about Mr. Knight, who was one of the co-discoverers, was looking for another variable, R. Coronae Borealis. And Jeremy has given me this. It's normally about naked eye. It occasionally drops down to magnitude 15, which is a hell of a drop, and then reappears, it gets back to normal brightness. Soot in the atmosphere that's making it appear faint. And it apparently faded in May and then got back to normal brightness. But it's still worth having a look to see if this. So if you're looking for, see if T. Coronae Borealis gets brighter, have a look for R. Coronae Borealis as well and see if it's actually getting any fainter. So the two are not too far from each other, and certainly you can observe this with binoculars. It's a good thing to do. And then we've got another interesting variable, which is perhaps more for a telescope. Jeremy has been talking about dwarf novae. This one is normally about magnitude 15, but rapidly brightens up to magnitude 12, then drops down again. But every so often it gets up to about magnitude 11. So there's these big bursts and then there's these shorter bursts, which are separated by, 3 to 10 normal outbursts. And this last super burst was in just a few weeks ago in December. So again, this is another one, if you've got the instrumentation, well worth monitoring. I don't know how this is going to show up at the back, but this is the night sky that we would see between this meeting and the next BAA meeting. We've got Orion, this would be in February, about 8 o'clock. We've got Orion, we've got Jupiter, Mars, Uranus near Jupiter, Venus setting. And there's so many interesting objects to see in the deep sky, whether using naked eye, binoculars, a telescope, or doing imaging. There's certainly other variable stars, and we've just mentioned earlier. I mean, there's R Leonis, which is a long period variable. We've got Myra, we've got Algol, the famous eclipsing binary. Loads of double stars, if you're into double stars, like Castor, Mizar in Ursa Major, various double stars in Orion as well. Lots of clusters and deep sky objects to look at with binoculars. Amongst my own personal favourites are the 3 big clusters in Auriga, 36, M36, M37 and 38. And of course, the big cluster in Gemini in M35. But if we think of the winter and deep sky objects, obviously we think about the Orion Nebula. And this is an impressive object, no matter what telescope you've got or whether you take any imaging. This is a nice image by Adam Rawlinson. They're using a 200mm cast. And again, coming back to sea stars, I know a lot of people use them. You can get some really fine images of the Orion Nebula with quite short exposures. It will show the sort of dark material through it and the bright arms as well. Another nice object, although faint to see, is the Horse Head Nebula. And what we've got here is Zeta Orionis, one of the belt stars, the Horse Head, and the Flame Nebula as well. And this was taken with a 100mm refractor, so not a massive telescope. And I think that is a really nice image. There's several nice images of the Horse Head on the BAA website. And this is a really splendid one indeed. It's almost like a 3D structure. Difficult to see visually, but I think even with small telescopes and imaging, you can actually capture this. And another thing in the winter sky in Monoceros is the Rosette Nebula. It's a large object, but rather faint. This is a nice image taken by Graham Stanley. That actually fit the whole thing in. I think Graham said he was going to do a montage at some time. There's a cluster in the centre, which is easy to spot. But again, it's a really nice object to have a look at. And of course, we've just had Christmas, so it seems fitting just to finish off with the Christmas tree cluster. This is a nice image taken using 150mm Newtonian, so you don't need big telescopes to take nice images. It's got the Christmas tree cluster, but it's also got the Cone Nebula there as well. And again, this is in the constellation of Monoceros. So lots of things are going on now. Maybe we'll get some more aurora, hopefully we will do. We've got a nice eclipse of the moon coming up in a few months' time. Jupiter and Mars are well worth having a look at as well. And so lots of things to see and do with either naked eye, binoculars, or a telescope. So I've come in a little bit early, which is what I planned. So with that, thank you very much for listening.
Oh, sorry about that. Thank you very much. Right, that's excellent. You see, when you set the bar that high, I'm not going to get another volunteer, am I?
Well, Nick does it.
Many times for all that do. I think Paul's another one that's a regular for Sky Notes. So thank you very much. So just a few things then before we finish for today. Whilst I was sitting there, I thought I should mention to you, we are planning a meeting in Orkney. And have a look on the website, because if you do want to go, I assure you, you need to get booking now. Yes. Grab those flights, and accommodation is scary, I have to say, but I've been there a few years ago, more looking at birds actually and archaeology stuff, but fantastic place to go and visit. And Canon Potter is hosting it. It's, I haven't the dates, the tips of my fingers.
September the 5th, 6th, 7th.
5th, 6th, 7th. So yeah, it is a wee bit away ahead. So you do need, but you do need to book early, book often. And then I have to admit to a certain amount of bias about this next one. There was discussion at council today that we are thinking, and I don't know whose idea this was, but that we might go to Ireland next year because we haven't been there since our BAA meeting in 2019. So there are cunning plans to see where we might host a meeting in Ireland. Dublin is extortionate. I know that is one of the problems, but my old university there might be able to do something for us at Trinity in the middle of Dublin, which is always a lovely place to base, or we're thinking maybe go out to Dunsink or somewhere like that. So these things are in the offing. So when you come to plan your holidays, just think, well, put a wee bit of budget aside, or an Orkney, a big bit of budget aside for something like that. So just other things to bear in mind as the year goes by. Wonderful meeting this evening. I hope you enjoyed it as much as I have. We have so many international, national and international talent there, people submitting observations. The talks this evening I thought were wonderful, all of them. And of course, we have our guest of honour, and it was an absolute pleasure for you to meet you tonight and to see you. So just leaves me to say the next meeting is the 26th. March, yes, 26th of March. I hope to see you all there again and hope you keep well, warm and healthy until then. Oh yes, Young Master Meeting Secretary, Mr. Floodgate. Oh.
So can I just mention as well, if Andy Wilson hadn't have been here today, then we'd have got nowhere. So thank you very much.
You did preempt me because I was going to say a special thanks to my three musketeers here, the three engineering musketeers. Andy, as you rescued us, Nick, for also coming in and groveling around the floor a lot. I'm not quite sure what we're doing there. And also to you, Thomas, who got thrown in at the deep end, your first council meeting, and then you're also trying to sort out our IT for there and there. Yeah, I apologise for the disruption from the Institute of Physics, but you know they do us a big favour in letting us use the premises here, and certainly those who remember sitting on very hard benches at Burlington House will be glad that we're here and not there. So I hope to see you all quick bevy in the parcel yard at the back of King's Cross Railway Station. It is accessible. There is lifts and whatnot for those of you who struggle for the stairs. I know that feeling. And see you all in March. Safe journey home.